it depends case by case based on the customer data complexity or the use case, right? Or maybe what domain of data modeling you are solving for. The next step will be description of, generate the description of each and every attribute, right? You can use a custom agent there. Now, what we have seen, like, for third-party data products, there are number of different documentations available over the internet. Or SAP ERP systems, there will be SAP documentation, right? Or think about in a kind of custom data products built within the organization. There can be some documentation available within the organization in their SharePoint or in their PDF documents or Word documents, right? So for each case, right, your description generation attribute-wise will be different, right? That depends on the inputs, right? Next step will be, once you are done with the data description generation, maybe you classify the attributes, right? Where the attributes are key attributes, identifier attribute, description attributes, measure attributes, or maybe flag attributes or audit columns, right? So it depends based on the description. When you give the additional context about the data that you are giving, or the business context, then you can classify it in a perfect manner. Once that is done, you eliminate columns. Maybe measure columns you can completely eliminate, correct? You can eliminate the description columns. You can eliminate the audit columns, or the columns which contains null values, right? They cannot be part of your candidate key or primary key, correct? Then you go with a single column candidate keys identification, where you pick up the columns where the unique percentage is more than 90% or close to 100%, and then you do a semantic analysis among the shortlisted column. Finally, you come across all the columns which can be part of your, or which is a potential candidate for the candidate keys, right? Which will define your row uniquely. So you can have a debating agent there, right? To do that semantic analysis based on the business context, based on the attribute description, data pattern, data profiling, all of those. Once the single column candidate keys you have identified, then you will go for multi-column candidate keys, where first you shortlist the columns where the uniqueness is more than 75%. Once you shortlist, you generate, or you sort of ideate the triples or tuples, right? Or a combination of columns that can formulate a unique or identify a unique record, right? And then with those, you do a semantic analysis again, that what combination will be, you can define which are potential candidate for a candidate key, right? Or uniquely identify a row. There you can apply or use a review and plan and review agent, or maybe which an agent will plan and then again review, and then again it will go in iterations, and then finally it will shortlist the tuples or triples, right? Finally you shortlist, and then, so the point is, there are agents. You apply LLM, you create agents, and then you do custom coding. It's a mix of both, right? The message that what I'm trying to say is, it's not a simple set of prompts that is working to identify or do all these activities, right? All these elements of engineering is there to finally work at that scale. But with all this, can we say that the data modeler or data analyst roles can be eliminated? No, certainly no, right? Because what we have seen, to stand up this tool in customer environment, contextualize it, right? All of those, it needs time. It needs a review with the functional team, with the data modeling expert, data analyst, and all of those, right? All those people will spend time, review, and this tool will work side by side, in a way like in an autonomous mode, in a co-pilot way. It will generate the recommendation, and then somebody need to review and go at the next step, provide human feedback and go at the next step. Now you think about like one particular thing, it's so much of engineering. Now you go back and think like, deep understanding of source data, how would that look, right? There will be hundreds of agents working in an autonomous way, and you will have an agent catalog where all the agents are there. Now you kind of, based on a given problem, it will identify, pick and choose from the agent catalog. It will define, right? The system will define in an autonomous way how the agents will run, in which order. All the orchestration will be identified dynamically based on the use case. And then finally it will run, right? And then with the human feedback also. So, what we have done in Tiger, we have created a prototype which will, which is very, very common, and we have implemented for multiple customers, which is very, very successful one. We'll quickly have a demo of that.
Leveraging this agentic framework, the TigerGen AI-powered assisted data modeler not only streamlines data modeling, but also ensures precision, efficiency, and future-proof adaptability, making it an invaluable tool for modern data teams. The first step in data modeling is gaining a deep understanding of the source data feeds, a traditionally time-intensive task that requires extensive manual effort. With Gen AI-driven automation, users can simply upload source data files for rapid, intelligent analysis. The system automatically detects attribute correlations, maps dataset relationships across multiple sources, and identifies inconsistencies that could impact modeling accuracy. What once took weeks of manual profiling is now completed within minutes, enabling data architects to build an optimized and well-informed data model with greater speed, accuracy, and efficiency. When data modelers work with unfamiliar domains or receive third-party data, understanding column meanings can be a significant challenge, often leading to delays in the modeling process. To address this, we have developed and integrated an automated data catalog creation solution that intelligently generates accurate column descriptions in real time. This automation eliminates the need for manual documentation, reducing effort while ensuring consistency and accuracy. By analyzing data patterns, metadata, and contextual relationships, the tool provides precise, standardized descriptions, enabling modelers to quickly grasp column meanings without relying on prior domain knowledge. This not only accelerates the data modeling workflow, but also enhances collaboration and data governance by ensuring well-documented, easily interpretable datasets across teams. Users can leverage the Alter Primary Key button to modify or add primary keys seamlessly. Additionally, they can provide instructions in natural English, which the LLM intelligently interprets and processes, ensuring accurate updates to the data model. This simplifies key modifications, enhances usability, and reduces the need for complex manual configurations. Post-analyzing all the source data files uploaded, the tool shows relationships between datasets in the form of ER diagram. The tool intelligently suggests data quality DQ rules for attributes identified as critical data elements, and based on user selection, generates the necessary inputs for running DQ checks. It seamlessly integrates with existing data quality frameworks, automating DQ rule generation to enhance data accuracy and governance. Second step of the data modeling activity is to generate the conceptual data model. The tool displays relevant concept suggestions for the final data model. Users can review, rename, or add missing conceptual entities while applying organization-specific standards and rules. Once concepts are finalized, relationships between conceptual entities are generated and visualized through a diagram. After verifying the conceptual model, the data modeler saves it to proceed to the next phase. The next step in the data modeling tool is the generation of logical data model. Users can also upload an existing data model, which bridges the existing model and new source data. The system suggests facts and dimensions from the new source for analysis. The solution can also map entities from new source to entities in the existing data model through semantic matching. The tool identifies primary keys for new entities, generates relationships, and generates logical data model visualization. The solution automatically creates physical layer with naming standards of the organization and recommends partitioning strategies for the tables. The tool shows lineage information for attributes along with primary and foreign keys and generates DDL statements, finally allowing the user to save the silver layer model.
So we're slightly over time, but there is a Tiger Analytics booth out there. We'll take all your questions if you have, right? Maybe you can stop by there and then ask your questions, please. Thank you very much. Thank you.
Check. Thank you so much, Senthil and Sanjay. That was a lovely session. I can see the room is full. Please, there are some seats that are empty here. Please do make sure to fill them up so you don't need to stand. Up next, we dive into how American Express is building best-in-class risk products to power smarter, faster credit and fraud risk decisions. Leading this session is Neeraj Munga, Vice President, Risk Products and Data Strategy at Amex, who oversees a critical roadmap for risk platforms across both US and international markets. Yeah. He'll share how Amex is leveraging data engineering and technical product capabilities to support high-stakes decisioning across businesses. Neeraj brings over a decade of experience at Amex, having held diverse roles across businesses units since joining in 2012. Unfortunately, Neeraj couldn't join us, but he was really kind enough to send us a recording for the session. So please do sit with us, enjoy the session. You have the screens on both of my sides. So please sit back and enjoy the session. Thank you.
Hello everyone. Thank you very much for joining us for this very special session on building best-in-class risk products at American Express. My name is Neeraj Monga and I'm currently managing the responsibilities of Vice President for Risk Products and Data Strategy in American Express. I joined the organization in 2012 and have been fortunate enough to be a part of 6 different teams. I've had immense learning opportunities throughout my career with American Express, while working with brilliant colleagues from diverse backgrounds. Every day is a new learning day for us in American Express, as there are very interesting data and engineering problems to solve within the organization. Founded in 1850, American Express has transformed from being an express delivery service company to a premium payments and lifestyle brand powered by technology. In fact, we recently celebrated our 175th anniversary on 18th of March this year. Every year, American Express manages more than $1.5 trillion worth of billed business for its card members, with 100 million merchant locations on the global network, over 100 countries and territories. We seek to provide world's best customer experience to more than 140 million card members. We're a global organization with 75,000 colleagues across 55 office locations and a very healthy annual revenue of $65 billion. We are proud to be ranked number 4 on Fortune 2025 list of best companies to work for, and number 10 on world's most admired companies. Within India, American Express has more than 21,000 talented colleagues across multiple business units, including credit and fraud risk, technology, finance, consumer, commercial, merchant services, enterprise data and digital services, and few others. These business units work together to drive growth for the company using cutting-edge technologies. Today, we're going to focus more on credit and fraud risk organization. We talked about $1.5 trillion worth of billed business on American Express every year. That translates into billions of transactions every year. For us, these are not just the transactions. For us, these are billions of customer experiences. And each of the customer experience matters. Imagine you have gone for a fine dining dinner with your family and friends, and the transaction gets declined. Imagine you're dealing with a medical emergency, unfortunately, and your transaction at the hospital gets declined. On the other hand, imagine some fraudster takes over your account, tries a $5,000 transaction, and it gets approved. There's very, very little margin of error in everything that we do. Whenever you swipe your card, or tap your card, or do an online transaction, usually within a few seconds, you get to see whether the transaction is approved or declined. However, most of the time during this transaction is the network time. When one machine is talking to the other machine and the other machine is talking to other machine, finally, when that authorization request reaches American Express, it comes to a system called CAS, Credit Authorization System. For every incoming transaction, our world-class systems analyze more than 12,000 variables, executes thousands of business rules and multiple machine learning models, and immediately takes decision whether the transaction should be declined or approved. All of this magic happens within a few milliseconds for millions and millions of transactions every day. Similarly, when a prospect or an existing customer applies for a new card on our website or through other channels, our world-class systems perform internal matching to see any past delinquent behavior, real-time calls credit bureaus to understand the overall health of the applicant, executes advanced machine learning models and thousands of business rules, and takes decision on whether the application should be approved or declined. Again, all of this magic happens within a few seconds for tens of thousands of applications every day. Again, these are not only applications, these are customer experiences. These are people who might be in the urgent need of a credit, and any incorrect decision that we take would directly impact tens of thousands of lives every day. Decisions on these billions of transactions and millions of applications is based on the gold mine of internal data and external data that enables us to take best in class risk decisions. There is a very large and complex data landscape within American Express with more than 1,300 tables, more than 200 applications, more than 350 models, more than 50 external data providers, more than 50 non modeling tools, and more than 150 external data feeds. Over time, we have developed highly sophisticated data platforms that enable us to build scalable solutions to drive business growth. Using this wealth of data and cutting edge technologies, American Express has developed very robust risk products that enable us to maintain industry best credit and fraud metrics. And yes, we do lead by a huge margin as compared to the competition. Building blocks to these risk products are data engineering, product mindset, low code, no code tools, agile operating model, AI and machine learning models, and data governance. Let's briefly touch upon each of these. We use more than 700 systems of record and tens of thousands of variables for taking credit and fraud risk decisions across entire customer lifecycle from onboarding to authorization to customer management to collections. It makes it highly complex to use this wide variety of internal and external data because there are multiple systems and sources, internal and external. The data formats are not standardized across these diverse and inconsistent data sources. Hence, we have developed highly sophisticated, organized data layers that provide standardized data variables with strong governance and high efficiency. These ODLs act as a single version of truth for the entire organization. For production and analytical use cases, including risk strategies, models, senior leadership, MIS, and analytics. Similarly, we have developed an engine called Third Party Data Gateway that acts as a single touch point for all real time integrations with third parties, including credit bureaus and other data providers across multiple countries. This data gateway enables more than 1 million data pulls every day to enable credit and fraud risk decisions across multiple markets, across multiple journeys. And this is done with very, very high quality standards, very high scalability, and reusability. Historically, we have primarily developed our capabilities on prem. However, there is an urgent need to provide scalability and agility with fast paced changes in the technology landscape. For instance, there is a time lag between us receiving the data from the bureau in a batch process and to the time we enable that data in the decision engines for real time decisioning. We're targeting to significantly reduce this lag with public cloud transformation for selected use cases. Early results of this public cloud adoption are very promising. For some of the highly complex batch processes, we are observing up to 90% reduction in cycle time on public cloud as compared to the on prem setup. This would help in significant business benefits with incremental loss savings, effective model scoring, timely fraud detection, and timely business insights for the senior leadership. Be it data platforms or decision engines or massive data lakes, we manage everything with a product mindset. First, we push ourselves very hard to understand the why behind the project. Why do we need this requirement to be in place? Why are we prioritizing this over other projects? We keep our users first and foremost in everything that we do. And yes, we do focus on the final outcome. Then we have sharp focus on the business value driven by the initiatives and prioritized by the return on investment. We focus on building simple and lean solutions by breaking down complex problems into smaller logical chunks which can be solved easily. We are a global organization with customers across multiple countries. Each of the countries has its own requirements and complexities. However, we being the product team, we always strive to build global solutions which can easily be scaled across countries with minimal customizations. Last but not the least, we focus on driving agility by building robust processes which are nimble and flexible as per the dynamic business requirements. Over years, we have learned it the hard way that it's relatively easier to develop new products by using custom coding for each of these. However, it is extremely difficult to maintain these custom solutions over time. Hence, we have invested in developing in house low code, no code tools that are significantly helping in building scalable solutions. These low code, no code tools are easily portable and language agnostic. Also, these are enabling great agility with quick time to market and having lesser dependency on technology specialists. We have been working in three different operating models as per the complexity of the projects in the organization, program increment as per the scale agile framework, continuous delivery operating model, and fast track operating model. We have been successfully delivering critical projects using program increment in the organization, where multiple teams need to come together to launch massively complex projects using multiple release trains. Additionally, we have operating models of continuous delivery and fast track, which are used to deliver on the journeys which have reached steady state and require relatively small scale changes. These continuous delivery and fast track are highly efficient in supporting business requirements, which require quick turnaround time and speed to market, especially in the scenarios when the macroeconomic conditions are dynamically changing. American Express has been one of the pioneers of using AI and machine learning in payments industry. Using the power of advanced analytics, rich data sources, cutting edge technologies, we have developed highly sophisticated models which are helping us in various business processes across the organization. These models are helping us in better detection of fraud cases, providing better servicing to our card members, identifying best customers to acquire during onboarding stage, reaching out to best customers for marketing, finding the best customers during the collections, and way more efficient processes for doing data anomaly detection. Over time, it became highly complex to maintain and implement these models in multiple customer journeys and have had number of challenges. Hence, we have developed an in-house product called MAS, Model as a Service. MAS is acting as a central repository of all the credit and fraud risk models. But models are deployed once using CI/CD pipeline and are utilized across multiple journeys in a standardized fashion with very low maintenance and faster turnaround time for the deployment. MAS is also helping in more optimized and automated testing using large data sets, which was extremely difficult in traditional systems. It is also helping us in reducing the manual touch points for the model implementation and helping us in significantly reducing the operational risk. Being a responsible financial services organization, data governance is foundational to everything that we do. Since we use data for the decisions of billions of transactions and millions of applications, we have very strong governance on the quality of data. Imagine a third party data provider starts sending us customer financials in cents instead of dollars. It would have severe implications on critical decisions like line assignment. To manage such risks, we have developed strong preventive and detective controls for data quality in our ecosystem. CDIT, or continuous data integrity tracking, is one of the best in class data quality products that we have developed in house. It is helping us in maintaining very high quality standards by tracking and monitoring the systems of record, organized data layers, output of risk models, and risk strategies, eventually enabling the organization in maintaining industry best credit and fraud risk metrics. Thank you very much for joining us. Hope you found this session to be relevant and engaging. Wishing you all the best in your data engineering journey.
Check. Thank you so much, Neeraj. Couldn't thank you in person, but we will, of course, convey our regards. Please do connect with him on LinkedIn if you have any questions regarding this session, and he would love to answer your queries. We have a bit of time in our hands before our next session. Please do grab some coffee outside. We'll take a quick 5-minute break, and y'all can come back again sharp at around 11:30 for the next session. Thank you so much.
There exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
Fit kernel requirements.
Help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product.
It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually a call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With ICEDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. ICEDQ, data reliability engineered.
Check, check. Okay, thank you so much everyone for joining back so promptly. We have our next session that dives into a crucial enabler of effective AI, that is context. Titled Architecting the Contextual Layer, Powering Next-Gen AI with Data Engineering, this tech talk will uncover how data engineers can build the contextual backbone that allows AI to generate truly strategic insights. Joining us are Mansit Suman, Engineering Manager at Mathco, and Tapas Das, Data Architect at Mathco. Mansit brings a strong track record of delivering impactful data engineering solutions across CPG and retail, while Tapas, with over 12 years of experience, has deep expertise in data platform modernization and real-time pipelines. Together, they'll walk us through practical tools and steps to architect data systems that bridge the gap between raw data and business-aligned AI intelligence. Before I call them on stage, I request all of you all to please take the empty seats that is around. And without much further ado, can we have Mansit and Tapas on stage? Thank you so much.
Sorry. Okay, welcome everyone. So I'm Tapas, been working as a data architect in Mathco with over 12 years of experience. I've joined with Mansit, who is also part of the engineering team at Mathco. So today we'll be going over architecting contextual layer and how it can be used to power next-gen AI systems, right? Now, before we go any further into context, let's first understand why there is so much buzz around AI and Gen AI specifically, right? How many here have not heard of Gen AI? Oh, there are a few unicorns here who have not heard of Gen AI, which is interesting. But contrary to unpopular belief, Gen AI is here to stay, and there are a lot of enterprises who are using Gen AI in their day-to-day operations to revolutionize their operations and also bring better actionable insights out of it, right? The numbers speak for themselves. So if you look at what Bloomberg is doing or JP Morgan is doing, we can see that there is immense potential in using these Gen AI systems, right? And we are also seeing that there is a lot of push happening from different enterprises like Microsoft or Google to make Gen AI more accessible, be it the launch of small language models or one-bit LLMs, which can run on CPUs and doesn't require any big bulky GPUs in order to run inferences, right? So how can we make Gen AI more intelligent, right? That's where the context comes into the picture, right? Because even if you go to ChatGPT right now and you try to search that, can you give me what is my sales forecast for this year? It will not be able to give you an answer because it doesn't know what your company does, what your organization is, what your business line is. That's where context happens, right? So I'll take a small use case of something that we have solved for one of the retail customers that we worked with, right? So we were given a very simple problem statement, right? We were asked to build a personalized recommendation engine, which will be used to do personalized ads and targeted ads for their customers, right? We went through a lot of iterations of Gen AI, LLMs, and how we can make it more intelligent. But ultimately, the secret sauce to building all of this is the contextual layer, right? So we have given a small snippet of what are the different stages that we went through. So because we were dealing with customer data for retail, right? So the data is coming from so many diverse data sources, right? So there is point of sale systems, there are digital stores, physical stores, there is profile information, demographic information, right? So all of this information gets captured in the integration layer. From there, we start building the contextual layer, which is the secret sauce to this application, right? Where we start collecting the metadata about it, the vectorized embeddings, the semantic tags, or the knowledge graphs information, right? And which all of this gets stored into a storage layer where you can use vector databases, knowledge graphs, traditional data warehousing applications, feature stores, so on and so forth, right? This data eventually gets used to power the AI systems, be it the recommendation models, the customer 360 dashboards, be it the segmentation models or personalization rules that you want to use, right? And eventually how we hand it over to the business users, data analysts, the technical teams downstream, right? So that's where we built an access layer as well, be it exposing it in terms of APIs, like marketing APIs, or even analytics platforms, right? So that they can slice and dice the data, they can ask questions to it, interact in natural language, and make better decisions based on that information, right? And if you look at the numbers, we were successful in achieving that. We were able to give a richer customer experience, which resulted in 40% increase in the customer engagement, and also increased the customer lifetime value by 42%. Now, going further, if I had to break down the structure that I showed there, right? So essentially, it's 3 different pillars that work in harmony to build an intelligent AI system, right? So one is obviously the model itself, where you build your LLM models, you decide the hyperparameter tuning, you define the context size. Next is the engineering techniques, right? What kind of model you want to use, whether you want to do one-shot learning or few-shot learning, what kind of data formats you want to use to train your models. And the third and the most important one is the contextual data, right? Which is where we see a lot of technologies like RAGs, NLCs, user case informations coming up, right? So what does this contextual layer do, right? So if you look at any RAG-based application, what it helps us is factually making sure that the AI responses are factually correct. So it grounds that information that the AI is giving us, right? Making sure that it's relevant in terms of the context in which that question is being asked, right? But is it so easy to build this contextual layer? Now, that's where I wanted to first showcase like where all the context can come from, right? So it can come from so many different places. There is data and metadata information, which is where you capture the data asset descriptions, the column level descriptions, data classification informations, data dictionaries. Then there is the domain and subdomain level informations, org and persona level information, right? Org hierarchies. Like let's say for the same application, if a CXO level person is asking a question versus a manager is asking a question, the system should be able to understand based on the role of that person what question or what answer to give, right? Because if a manager is asking, his area may be a smaller area, whereas a CXO is looking at a much uber level compared to that, right? Then we also have business workflows. So the system should be able to understand using this context that how the response it is giving is going to help in the decision-making process, right? Which will help us to build more intelligent assets, right? So definitely it's not an easy task to get this context out, because many of it is also institutional knowledge or tribal knowledge which stays in people's head and not really documented somewhere. And even if it's documented, it's not always up to date or always properly maintained, right? Now, has anyone here tried creating their own bots? Anyone? Okay. A lot of people have tried it. So what's been the most common problem in creating a bot? Context. The reason for that is all of these LLMs, ChatGPTs, and all that we try to use, they have been trained on a set level of information, right? That may not always be relevant to you, right? Let's say the same retail use case that I took, if that LLM doesn't even understand what a retail business is or what that customer does, the responses will always be fictional, right? It's like always having that overconfident friend who will give you any kind of answer you will ask, be it about sorcery, pottery, medieval knowledge, rocket science. It will give you an answer, and very confidently. You may even trust that, okay, the answer may be right? But most of the time it will be fiction if there is no context behind that answer, right? So that's where these are some of the common challenges that we faced when we were solving this use case. Lack of a domain metadata, right? So all the metadata that we're capturing to build this context, how do you store it? Or more importantly, how do you collect all of this information from so many different variety of sources, right? So that is one. Second is you have so many different kinds of data, how they're related to each other. So the relationships are always missing, or it's like a tribal knowledge that is not documented somewhere, right? Which is also something that we had to capture. Then the coverage of the information, right? So we have a lot of information sitting in PDFs, PPTs that are presented out to a set of people, but the LLM is not really aware about it, right? So that is also something that we had to capture to build this context out, right? And the most important is to always keep this context up to date, because there is always something new going on in the institution, organization, new policies come up, new regulations come up. How do you keep this LLM up to date, right? So how do we build this context? So that is where I'll start with a high-level overview first, and Mansit will do the deeper dive from that point onwards. We talked about structured and unstructured data, right? Now, structured data is easy to handle, I would say, because we have been doing it for so many years and really well using traditional RDBMS systems. But when it comes to unstructured data, that's where the cracks start to appear, right? So if you have PPTs, PDFs, images, audio files, video files, right? So you have to convert all of that into a format that the LLMs can understand, right? So that's where we start going into text embeddings, text chunking, or using OCR to get insights out of the image that's been given, or start transcribing the audio or video information, right? Which gets stored and end of the day into either embeddings store, a vector DB, or will be used into the information retrieval process that we will use as part of the agentic system, right? Now, to do a deeper dive under context, like I showed, there are 4 pillars. There is metadata, there is vectorization, there is knowledge graphs. I forgot the last one, but Mansit will do the deeper dive from that point onwards. Mansit, over to you.
Okay. So surely metadata is important. Every data engineer would agree in this place here. But when we talk about metadata, what do we talk? We talk about like schema footprint, what is the data type, what is the data quality rule, what is the range of values a particular point of column or particular table should cover, what is the source system, what is the loading strategy. So metadata is not just that. It also covers the business glossary. What is the definition of the column? What is the purpose of the table? What domain does it belong to? Is it marketing? Is it loyalty program? Or what does it mean? And in case of unstructured data, that is like from documents, from presentations, the most important thing that we cannot like train so basically cannot vectorize all the information that is present, right? We have to understand the sentiment out of it. We have to summarize what the document is saying. So that becomes very important. Then another thing that helps in getting more context about a column is descriptive stats. You all might have tried using Kaggle, right? Kaggle competition. In Kaggle competition, when you go, you just don't see the sample data, but you also see few descriptive stats, like what the histogram of it, what is the range, what are the distinct values present. So that also becomes a very important field for context. Then last but the most important again is governance. We don't want like certain people to have certain accesses. Even if we are vectorizing our documents, vectorizing our summaries, we have to make sure that certain information should not be exposed to certain people. So adding compliance tag, adding sensitivity label is very, very important. And this has been inspired by PayPal data contracts. It's an open source GitHub repository. Please do have a look and try to implement in your projects also if there is a way. But don't you think like all of this information is too much, right? So certain things from code we can definitely do, like schema footprint, descriptive stats, and probably some elements of governance. But still, again, business glossary is too much to fill in. So how did we solve for all of this is something we want to discuss. Okay, next slide. Yeah. So we made sure through metadata has to be enriched through our ingestion framework. So instead of a business user raising a request to a data engineer that I want to integrate this table, what we have done is through a UI, the business user can add data through a UI. So basically, we have all the connectors. Like for example, it can be a third-party connector, it can be an Azure SQL connector, it can be an API connector. So all of these are available, where a business user will go to a UI and register the data they want to do. So with basic information, like where the location of the file is, what data they want to load, and is there a transformation step that is available. Once that is done, there are few validation checks that that information needs to pass through. Once that is done, data is loaded and passed into the required format in a bronze layer. For like big tables, we go ahead with like delta lake formats, and for unstructured data documents, it should be converted into markdown or the textual format we can call. So once that is done, we calculate the descriptive stats out of it. What I mean by descriptive stats is the other one that we saw, like what is the min-max range, what are the distinct values, all that information are being calculated. Once this is done, a notification is sent to the user, and the user can go to the portal and enrich, add more business details to it, business glossary details. Why in two different steps? Reason is, we don't want business user to fill definitions for each and everything, like 11 columns, not 11 definitions. It becomes hectic, right? So what we have done is, using the descriptive stats, the things that have been calculated, there is a AI recommender, like through Azure Functions, you may put it. So through Azure Functions, we are using this descriptive stats, the metadata that has been collected through code, and asking the business user to fill in. So AI suggestion will come, and based on that, the SME or the business user can review then and there, and sort of proceed for the next step. Okay, our metadata is very solid now. A lot of information covered. But it is still enough for the agent's context. Metadata is there. We can just directly vectorize the metadata. But certain questions will be like this from business users, where they will ask, how has been the loyalty program effectiveness for a particular region, like consider California. So right now, whatever context we have collected, it just gives definitions. It just gives like where the data is located and things like that. But once we start vectorizing it, the major problem that it has is, it loses the URL, like where the data came from. It cannot find which field it belongs to, like certain information. And multiple hits from the same asset looks like separate results. We don't really know what's happening there. So what we have to do is vectorization with tagging when it comes to metadata especially. I know it's a little expensive to do this all the time, but this is something will be very essential while we are using our metadata. So idea is, every embedding should carry a tag of the URL from where URI of your data set where it is present. If we are doing that, two things we are doing. One is, it improves the explainability. Explainability in the sense, like it will give you the site, when the semantic search happens, it will give you the result with also the explainability of why this particular search result came, like from which data set or which asset it came from. And also, most importantly, you will have URIs present. Let's say if the user want to deep dive more, the URI will help to deep dive to the data set and get additional details there. So how do we do this? it's simple. It's the metadata information that we have, the JSON file. We flatten it. We make sure the key and value is stored definitely, and chunks are created based on per fill method, per fill embedding method. So basically, the embeddings that will be created will have one key attached to it. Once that key is attached, like for example, business definition. Business definition key will be attached to the business definition embedding. Once that is done, we also tag with the URI of the dataset where it is coming from. And then observe everything to the PG vector DB, like or Pinecone, like whatever you can call. So yeah, vectorization with tagging is great. But is it still enough? We have collected context from like unstructured data, structured data as well, and also vectorizing metadata with tagging. But is it still enough? I'll answer in the next slide. So when you call, like keep data set in one side, keep business in another side, the metadata that we have kept is more closer to the data. What column is the definition? What table purpose it is? What domain it belongs to? But we also need, because the questions that will be coming from the business will be from their perspective, from their business. Like for example, I want to see how has been my marketing ROI. I want to see how the customer demographics looks like. So the way we also have to make sure that business process documents, that are the docs, PPTs, needs to be there. With that, something that has been very effective that we saw is a knowledge graph out of it. So I'll move to the next slide. Yeah, in knowledge graph, what we have tried to do here is, let's say team, marketing team. What data products that marketing team has to go through? Consider customer 360 view. What dashboards that data product contains, list of data dashboards, and what KPIs one dashboard contain, what data set that is belong to. So whenever user asks the question, it first goes through the knowledge graph, subsets the data. Like for example, I'm a marketing guy. I will go and ask, I need a marketing spend ROI. This marketing keyword will go and sort of see like what is the area of coverage that needs to be there. So in that way, we subset the vector data set we are taking in. Instead of like traversing through the entire DB, we are traversing only a subsection of that information. In that way, our information becomes more directed and more correct. Great. But again, is it still enough? Context from different sorts of data, vectorization, metadata is done, knowledge graph is done. Is it still enough? It's not enough. Because agentic systems that we talk about is not deterministic. It is stochastic, or you can call probabilistic. So the more things that we do, of course, like it will improve 1%, 2%, 3%, but we may stop at like probably 99.99%. But every percentage, depending on the domain that we are dealing with, depending on the use case that we are dealing with, every percentage plays a role. So it is very, very important that we proceed like 1 step ahead, 2 steps ahead to see like what can be done there. So putting it all together, we have all the data sources. We see like what is the right set of context that needs to be loaded from here. Then from our Omni ingester, it gets ingested. Metadata enrichment setup helps us add the metadata to all the data sets that we are doing. The compute layer helps us in parsing and conversion. Then all the context in the context service serving layer, we add the knowledge graph, the vector store, and the search service. It can be any search service that you can use. So and then access info. This is more critical, and that we can load it through our governance tool. It can be Azure Purview here, and all of this acts as a one layer that any agent can use, domain agents. Like for example, it's called customer agent. Now, like domain agent, like customer agent, there can be like multiple other agents. What we have seen in one of the other customers that we are working with, they have created MCP servers for 111 domains. So in that way, you can create, using those agents like one by one, you can build on top of it and like unlock like more number of use cases from there. Yeah, lastly, I want to end this presentation with a very important note that data engineers are the chef, and context is the secret sauce. And data engineers know what amount of secret sauce needs to be added to make the recipe really better. So yeah, like Satya Nadella said that SaaS will be dead, but data engineering is something that is going to grow from here on. Yeah, that's all I have.
Check. We have some time. We can take some quick questions if you all have any. You all can raise up your hands and we can have some mic pass. Yeah,
sure.
Please. Yeah, you can.
Yeah.
So, how big a context we can set to a AI agent?
So, that's a very valid question. Okay, so what has to be done is not like putting together everything in one place. So what we do is like we create microservices the way we create in a normal engineering setup. So instead of having everything in one place, we try to break it down so that traversing become much more easier from the how you chain all the things together. Like for example, there will be a planner agent. That planner agent will invoke each micro agents one by one and get it out. No, that's a very valid question. That may or may not be done. Like the knowledge graph that I was showing, that was done manually by like taking into consideration of an SME. If we do it through AI, of course, it will show, but the more the more the context we give from the human side, it is better. It is the thought process. Yes. Definitely. That is necessary. Human in the loop is definitely necessary to get things done. So while we are testing, we have to make sure the SMEs, like be it a data engineer SME, be it a business SME, has to be there. So yeah.
Hello, am I audible? Hey, my name is Anubhav, and my question is around the actual implementation that you would have done in your experience. And my question revolves around the setup that you showed around the knowledge graphs. Maybe it was an example, but I would like to know much about in reality how it looks. For example, you took an example where the knowledge graph had a node of marketing.
Yeah.
But how many implementations have you actually done where you have created something or the whole setup where different domains, for example, or let's say teams, marketing, operations, or something else would come on the same platform which you designed?
Definitely.
Because most of the things that I've seen so far are very point solutions. Maybe within marketing you would have a point solution to do something.
Definitely.
So are we really doing something on this scale where big enterprises are doing it for marketing as well as on the operation for the same data set?
So we started with a very small POC in SEM. Like while we were working with like few SEM customers, we started doing it and we saw like a good value there. So we thought of implementing the similar thing for marketing. So for now we have like done for SEM and marketing. So yeah.
Into one solution, is it?
No, different.
Different solution.
I'll take that also. So the way it's been designed, it's not specific to one particular domain. It depends on the context that you give, right? So similar to you have a orchestration layer when you create a data engineering pipeline, right? Same way we have created an orchestrator for Gen AI agents also. What that orchestrator does is based on the prompt that came in or the question that came in, it searches through the context to see what area it belongs to, who is making that query, what is the role of that person, and then it decides what answer to give. So for this particular use case that we showed, this is open to basically the whole enterprise, right? It's used not only by the marketing team, even with the SVPs and the CXO level people, because they also want to understand what is the marketing spend. That's why I said, regarding the knowledge graphs, we created the role hierarchy for everyone who is using this application. So if a CXO level person is coming in and making a query, his context is different because he's looking at a global level, what is the marketing spend. But if a manager comes in, he's maybe looking at a small region or a small department within that enterprise. So his context is different, right? So that way, we can scale this orchestrator with as much context you want to give or as much knowledge graphs you want to build around it, and it will give you the responses accordingly. It's completely scalable.
And that filtering of whether it is a CXO or it's a manager from operations, that happens while you enrich metadata with that data. For example, if this guy is a manager, then filter it out for manager first and then only give the answers.
Exactly. Yeah.
Okay. And nowhere we spoke about anything around evaluations if these systems are being evaluated.
Evaluation is a very critical place. So what we did is we went ahead with the business SMEs, like we kept them in loop, and there is a module that our Nucleus team has designed it. There will be Nucleus SME who would be there in this booth, like we can discuss with them.
Okay, thank you.
Yeah. So we have set of questions. Using that set of questions, we have validated as of now. Yeah, spot checks.
Yeah. So we have a team of prompt engineers and testers who are checking this live from time to time to see if the prompts are still making sense or not. In case it's not, then we go and tweak it based on requirements. Sorry, someone was asking something. Yeah. Specific LLMs, there is no secret sauce around it, unfortunately. It's a hit and trial, right? So you have to try everything and see then which one is making sense. We try to stay on the cutting edge. So this is built using the GPT 4.0 model that is out there right now. We are also experimenting with some of the smaller language models that are coming up from Microsoft or Google as well, although those are not as powerful, obviously, because of the size of the model and all that. But right now, it's purely a hit and trial. You have to try every model, see which one is making more sense and all that, and go based on that. Yeah. Now, imagine a situation where it's a global customer which is spread across 10 different countries. So to talk to that person, you have to set a schedule, get into a meeting, ask those questions. He may not have time or may not have context all the time, right? So this is intended to be much more accessible. That is one. Second is, on the cost point of view, yes, there is a cost attached, but like I showed, the value that I got out of it in terms of customer retention, customer lifetime value, so the project in essentially paying for itself only, right? So it's not like I'm spending something extra out of my pocket. Whatever I get in terms of more customers, more richer experience and all that, that's going to pay for in the future for whatever I'm spending on the model or the infrastructure as a whole.
Yeah, actually, I want to add here. So the knowledge graph that I was showcasing. So while we were building it, it became a very important asset for them quickly, because everything in one place is something they did not think of. So yeah, that really helped, because it does not have like the notes with team, data products, dashboard. It also had like calculations. It also had the definitions. So everything you can see in one picture. So that really helped them in that way.
Yeah, I'm so sorry. Can we just take one last question from this side and we'll close?
We can discuss later. Yeah.
Can we have the mic, please, quickly?
So how do you control access to the data, or how do you control the context?
How do you control the depth of the knowledge graphs?
Okay, you want to take that?
Yeah, so there are like n hops that needs to be taken, right? So there is some interesting concept that Microsoft has written a research paper on, graph rag. Have you heard of that? Yeah, so it creates like different sets of community. Based on the question, we try to understand like how much depth we need to go, and based on that, it's decided like that's a package that does it. I have to like go through more depth. Yeah.
Okay, I think you all have more questions, but we are running a little out of time.
Yep.
So thank you so much for this amazing session.
Yeah,
Please
but
do connect
visit
with them.
us on the Mathco booth
Yeah.
if you have any further questions on this, and we can connect there. Yep.
Yeah, their booth is just outside, so do connect with them. Do connect with them on LinkedIn for more information on their session. Can we have a huge round of applause for them? Okay, moving on to our next session. Our next session is titled Reimagining Data Transformation with Co-Pilots and Low-Code ETL. This session will be taken by Shashank Mishra, who is a seasoned data engineer with over 7 years of experience solving complex data challenges across industries like aviation, pharmaceutical, fintech, telecom, travel, and hospitality. With expertise in modern data engineering and architecting scalable data pipelines, he's a passionate mentor and educator. Shashank is a data engineer at Prophecy, and he'll be leading us for our next session. Again, just a quick reminder, people standing there, please do occupy some seats this side. We have some empty seats here. Thank you so much. Shashank, all yours.
Cool. Good afternoon, everyone. Let's get started. So, short introduction. Myself, Shashank Mishra, and working at Prophecy as a data engineer, and that is what I am going to present today. So, let's quickly talk about what Prophecy is and the co-pilot capabilities of it to build the data pipeline very quickly, and how to use it, what is there for the data engineers and the data analyst. So one important factor for any data product to get successful, and it is heavily dependent on the high quality and well-governed data. And in order to achieve that, these two folks, the data engineers and data analysts, will be working together. And that is the part where two options in front of us, that how we are going to achieve it. So option one, and we will look at the challenges. So one thing is pretty sure, data engineers can achieve this. They can code all the transformation, but at what cost? Like data analysts, data engineers, both are working closely together. So data analysts bringing all the requirements, sending it to the data engineers. They are working on it, giving it back to the analyst. Then they are verifying whether it is up to their requirement or not, and maybe there might be certain changes, and again things are going back to the data engineers. So this cycle goes on, and that is the part where we are compromising with a lot of like capabilities of the data engineers, because they might not get a chance to work on the bigger pictures or solving the more complex data engineering problems, engineering challenges. They won't be able to solve it because they are just occupied in this whole back and forth of small changes, integrations. So what will be the impact on the data analysts in this case? They will be blocked because multiple tiny changes back and forth, so delayed output to the stakeholders. Option two, where the analyst can prepare the data on their own. But what is the risk here? The risk is all about the costing, quality, and security, because data analysts might be using the same copy of the data, writing their own logics, transformation, might be expert in different tools. So they are using the same thing and writing the same copy of the data. So costing part, definitely same copy of the data, different tools, more cost is involved. Quality, there will be a question like the data analysts are using the right patterns to solve that problem or not, as per the company standards or not. Then the security part, like the same copy of the data might get written at multiple places. So managing all those permissions, and there could be a security risk as well. So these are the two options where we have seen if data engineers are building it, then what is the risk? If data analysts are building it, then what is the risk here? So what is the demand of business in this case? So on the left, we can see self-service, where data analysts are using something which they are pretty much comfortable with, probably drag and drop features, building the pipeline very quickly. And data engineers can focus more on the scalability, performance part, and the productionization, data quality, etc. So both are sharing the responsibilities and things will be done very quickly. And that is the part where Prophecy is coming into the picture. So recently we have launched the Prophecy 4.0, which is primarily focused, we are calling it as a Prophecy for the analyst. So in this one, you can see 3 layers, the data integration platform, where you are building everything. You have multiple sources to connect with. It could be a SaaS application, different warehouses, different databases. And in between, you are using just the simple drag and drop features, configuring different components to apply your transformation. And behind the scenes, all the best practices are being followed. Be it the versioning, like your whole code base will be maintained on the GitHub, you can connect it, the whole CI/CD part, everything you are doing from the Prophecy itself, not juggling here and there to maintain the simple pipeline itself. And the cloud data platform, Databricks, so in the 4.0 version, which is much more focused towards the Prophecy for the analyst, so natively, things will be handled by the Prophecy on the Databricks compute platform itself. So this is the high-level picture, how Prophecy looks like. So what you can see on your screen, the very left, multiple sources we can connect with, and these are the entities which we are calling as a gem, like you are configuring the things here, and you can send it to multiple destinations. So the interesting point about Prophecy is not a typical low-code ETL where things are hidden from you, that what you are running behind the scenes. If I'm a data engineer, I'm building a pipeline, let's say more Spark-oriented. So although from UI, you are using the drag and drop features, behind the scenes, we are generating clean and optimized Spark code. You can see it, the entire code base, you can ship that code to even any like internal platforms you have, like you can build all that CI/CD. So like whatever is the implementation, nothing is hidden from the user itself. Like in multiple low-code ETL platforms, you might have seen, you are just doing the things from the front end, but what they are doing behind the scenes, you have no clue about it. And same for the SQL. If you are creating the SQL-oriented pipeline, so we are generating open source DBT code, which you can run on any type of warehouse, it be Databricks, Snowflake, and BigQuery. Similarly, for the Spark-oriented pipelines, you can have a multiple compute platforms, like your Databricks again, Dataproc, Synapse. So it is more like the IDE for the analyst and the data engineers. You are just coding your things, focusing on your logic, and you can have multiple compute platforms. It's not a low-code ETL platform which is giving you the compute capacity, just the ID, connect with any particular compute platform, and your whole pipeline will get executed on top of it. So you can see, like analysts can simply, if they have files in their local, they can put it there and analyze it quickly, or can bring from different sources. 4.0, where we have, as I said, much more focused on the more simplified and the automated version of scheduling the pipeline as well. So what you are building, it is actually going as the workflow in the Databricks itself, scheduled properly, and the observability part on the Prophecy itself, where you can see how your pipelines are running and all that. And this will be the major section where I have a demo as well, like it's already recorded one. I will show you that how you can leverage the Copilot capabilities, just give the natural language statements, and your whole pipeline will be ready in just one single click. You just register your data sets, just keep on feeding what all transformation you want to do, and it is going to prepare everything for you from the scratch. And the most important part where the data engines are not much comfortable, the documentation as well. Just select your pipeline itself, click on the documentation, and it will like completely document your pipeline as well. Simplified version control, that's what I said. Multiple versions of your deployment will be maintained, so any point of time you can revert back on any specific version you have, and you can see that the data analysts will be focusing more on the pipeline development, and the data engineers are focusing much more on the governance part of it. Cool. I'm not much into the PPTs because I would like to show you that when I said if you are a data engineer, you are building something. So just this is the simple interface of Prophecy. So let's say you want to build a particular pipeline. So there are four major components of it. One is Fabric, and Fabric is basically nothing, the compute environment. So if I simply go here and if I type DVX compute, so we are simply trying to create the environment where I can configure multiple kind of instances as well, multiple kind of job clusters, and as per my job requirement, and I can attach that thing, and similarly in the schedule pipeline, I can mention the same, that which particular compute or job cluster should be used. And for all the collaboration part, you can see the team section where all the users like who are collaborating on a project can get access. You can add it and give the required permissions to them. So this is the part where you can see it's the provider is Databricks, more focused towards the Prophecy for analysts. Now, if I switch to Spark, so here you can see Databricks, Livy, EMR, Synapse, and I can connect to anyone. Similarly, for SQL, you have Snowflake, BigQuery, Trino, Redshift. And similarly, for the scheduling part as well, for orchestrating the pipeline, we can go ahead for the Databricks and even the Cloud Composer, simply Airflow. We are using that one, and we can orchestrate the pipeline there. Then the another component will be the project, and project is something which is basically like it consists your pipelines, your registered data sets, and apart from that, all the UDFs you are writing, and whatever jobs you are scheduling there, it is going to contain all those things. So this is a simple pipeline, and here you can see on the right-hand side, I have different environments which I have created, different fabrics. I can attach it to anyone at given point of time, and here you can see these different clusters, because the fabric which I have created, I defined 2 job cluster sizes there, so any point of time I can use it. And let's say my pipeline depends on multiple Scala dependencies or the PyPy dependencies. All those things can be simply configured from here as well, the dependencies section, and during the runtime, all these things will be installed on your cluster very quickly. Similarly, now as a data engineer, you might be thinking how I can even optimize this pipeline, because I might need to pass certain Spark-related properties. So how I can do that? Come to the pipeline settings, and you will find all those things which you can configure, because as I said, behind the scenes, we are generating a open source Spark code. And this is the whole pipeline structure. You can see multiple categories, sources. If I want to go and I want to register anything, I have multiple options. Let's say test data set, bad in naming, apologies for that. So you can see multiple files, Parquet, JSON from whatever, like S3, ADLS, GCS from wherever we want to read, warehouses, catalog tables. So this is how we can connect to multiple sources. We can configure it. And then in between, we have these, in Prophecy, we basically call it gems, like the simple configurable entities at the end. Like let's say we want to filter some data on some condition, we can write it, proper expression builder here. And similarly, like the aggregate option, so you have the aggregate expression, you are using the Copilot capabilities here as well to write any expression, group by, pivot, whatever you want to do. So more of like proper drag and drop features where you are just configuring the things. Even if you are not a Spark expert, you are still generating the quality Spark code in the backend. And let's say if I just simply execute this pipeline, I would be able to even see the interims in between, which actually help us to debug the pipeline very quickly, that what a particular transformation is generating. Is it like as per the requirement, all the logic, whatever it is. So if I click it here, you can see in between, we are able to see the interims as well for the quick check, for quick debugging itself. And this is the part where magic happens. If I switch to the code part, and this is what I was talking about, that it is a simple quality Spark code. We are not doing anything where like the implementation is hidden from the user. You have your Spark code ready, now use it wherever you want to. Or if you simply want to use Prophecy for all that management stuff, you can manage it from here itself. And this is a simple example for the SQL-driven pipeline where we are basically creating the models. And as I said, the open source DBT code would be generated behind the scenes. So for an example, this one, models are nothing but the simple pipeline component itself where we can pull any table depending upon what fabric I have created. So the data warehouses basically in between performing certain operations. Then there will be a target model, which is eventually a view, a materialized view, or another table. Then we can have these models. We can read the data from these models. And behind the scenes, if I switch to the code view again, so you will see a proper open source DBT code. So this is how it is. And yep, now I think I should show you the main part, which is the Copilot capabilities of the Prophecy for analysts, that how you are doing it. So recently, one of our colleagues presented it, and I would be playing the same demo for you so that you have a better idea about it. So let's do that. Sorry, no audio, I guess.
Greetings. Today we're going to take a brief tour of the Prophecy Data Integration Platform, specifically the new Prophecy for Analysts, enabling self-service data preparation for business users. Let's take a look. We're looking at the Prophecy interface. Here you can see a blank canvas. The canvas is used to design a data pipeline to serve up data for various business purposes, analytics, data science, etc. Prophecy's UI enables, through a combination of drag and drop and the use of generative AI Copilot, to build out data pipelines behind the scenes, generating open source code that executes in your preferred cloud data warehouse. Prophecy never actually accesses your data directly. A couple of things to note here in the UI. You'll see here is my attached cloud data platform, in this case Databricks. You'll also see across the top what we call our gems. Our gems are the components that are pre-configured and ready to drag and drop into the UI to build out your data transformations and integrations. You can see the good subset of these here as I browse through. The other thing to note here is the customization. Because we are open source code behind the scenes, the platform is greatly extensible by that. Also note here in our Explorer on the left-hand window, you can explore different objects within the project. So project being a Prophecy construct to include objects that are respective of a specific business area, things like pipelines, data sets, etc., or apps, our new self-service mode for running various pipelines for a business user, and the ability to browse the various connected environments. And you can see here that I'm connected to my Databricks environment as well as a Snowflake environment, but we also have the ability to connect many other environments for inclusion into data pipelines, integrating data from many disparate data sources. What we're going to do today is we're going to build a very simple pipeline respective of a business problem. I'm an analyst. I've been tasked by my management to build a top 25 sales report, getting an understanding of who my top 25 customers are on a daily basis. So something I'd want to run nightly so that a dashboard on my executive's dashboard would be filled with the proper information every morning when he logs in. What we're going to do is we're going to leverage our Copilot. And I'm going to start by just, because I know I need to combine orders and customers, I'm just going to ask that question of the Copilot or prompt it. And you can see here that I'm combining orders and customers. Not technical terms, just natural language. I could use technical terms if I'd like as well. You can see here by submitting this, the Prophecy Copilot goes off, finds the available metadata based on my security profile, and from this configures a series of gems to combine those two data sets. So you can see here I've got my orders data, I've got my customers data, and it's configured a join between the two. That's great, but we want to take this further. Obviously, we want to get an understanding of who my customers are, where they're from, how much money they're spending, et cetera, et cetera. But before we do that, we probably want to do something like make sure our data is clean. So let's just drag a data cleansing gem here and attach that. You notice it attaches nicely. And what we're going to do is we're going to say, you know what, hey, let's remove any row that has entire nulls on every field. We're also going to select all of our columns, available columns. And what we're going to do is we're going to place nulls in that with an NA. And then we're also going to just get rid of some trailing and leading some white spaces. So we can do this in bulk across the entire data set, and we'll save that. All right. Now, let's take a quick run here. Now, you can always run this pipeline anywhere you want, and what's happening behind the scenes is the code is being generated behind the scenes. It's being submitted to our cloud data warehouse. And what it'll do is generate the interim sampling of that data, which allows me to see what the data looks like at any point in my pipeline so that I can troubleshoot or get an understanding that I'm doing exactly what I want to see. And you can see these interim samples being generated. The one I'm really concerned with here is the last one, because I want to see that indeed we have our nicely joined cleansed data here. But I also might want to take a look at some profiling information. So what we're going to do is we're going to enable the profile. You're going to get these nice little histograms of distribution of the values within each of these columns. And we can actually take this a little bit deeper by going into our expanded profile, where we're getting some even more metrics on the various columns that we are profiling, as well as the histogram we're seeing. And we can navigate here accordingly as we see fit across all of the columns in this data set. So my data looks good. So what I'm going to do is I'm going to come back out here and I'm going to apply some transformations. So what we're going to do is come over here to our prepare, and I'm going to drag in a reformat gem. A reformat gem allows me to select the columns that I want to work with, as well as build any new enrichment expressions that may be of value. So knowing that I'm going to work with customers, let's take our customer ID, let's take order ID so we can do an order count. And obviously I want to know how much people are spending. I'm going to rename this to sales amount to make it more descriptive going forward. And I'm also going to add a new enriched column called full name. Now, I'm just putting a descriptive name in the target column name there, and you'll note that the Copilot behind the scenes is proactive and actually recommends the expression necessary to generate that. Now, that's tremendously powerful because if I didn't know what the syntax was, it's going to tell it to me and create it for me. Now, it goes even further. I can actually invoke the Copilot and say something like, give me company name from email. Again, natural language, but in this case, it nicely generates a expression to generate the company name from the email field, right? The other thing that's great here from a Copilot perspective is if you do choose to build your own expressions and you make mistakes, as I'm very apt to do, I remove this parentheses, you see that I get a warning, and best of all, we can just use the Copilot to fix it. We'll apply the fix, go back, save, and we can go on our way. Again, a great time savings for anyone who does happen to make some fat-fingered mistakes as they're preparing their data. Okay, So for the sake of time, what I'm going to do is I'm actually going to just come in here, invoke the Copilot, and extend my pipeline with a series of prompts that I'm not going to bother with you watching me type. I'm going to aggregate total sales and order count by full name and company. I want to show my top 25 customers by total sales, and I want to reformat my total sales to 2 decimal places since it is a dollar value. So we'll submit that to the Copilot, and you'll note here that the Copilot goes away, thinks, evaluates the metadata, and in this case, creates 4 more gems of varying types and configures them as well. So we're aggregating, we're going to reformat to round our dollar value. We're going to order by that total sales aggregate, and then finally we're going to limit that to the 25 I asked for. So let's take a look at this. So we'll just run our pipeline up to this point. Again, you're going to see these interim samples start to generate. Our code behind the scenes is being submitted down to our cloud data warehouse. We're not actually accessing in the Prophecy environment your data at all. And at the end of this, you're going to see the output that I would expect. In this case, we're going to see our top 25 customers in descending order by total sales with their associated order count. Now, this is the exact information that I want to include in my executive's dashboard. So the last step here is really just to drag in a target and/or a table. And since I'm going to, in this case, write it back directly to a table in my cloud data warehouse, I'm just going to drag my table in here and connect it up. Now I can configure this here. Maybe I want this to go a few other places. Let's take this out. Maybe I want to write this right out to Tableau server. That's something that's possible. Or maybe I want to generate emails directly to my executive. That's also possible, as well as a number of other sources or targets that I can configure to write this data to. The important thing to note here is that we can generate this data. We can enable an end user to do it on their own, and then we can publish it really into any of the available targets necessary for the downstream analytics to take place, whether it be data science, BI, or just general output. Okay? A couple other things to note here. Now that I've built my pipeline, what is my least favorite part of doing any of this is documentation. Our Copilot come in here and will fully document our pipelines as well. So you can see here I've done an explain on my entire pipeline, and when I do so, we've now documented that pipeline and we can save that with it as well. Okay? A couple of other things to note here. You're going to see that we've got our the ability to manage and version this particular pipeline as we work and collaborate with others on it. So you can see here that I can save this to a draft. It's going to generate my description for me. I can save that draft, and then I can finally even navigate this from a version and draft perspective. And if for some reason I need to revert to a former version, I can restore that version as well. So now I have my pipeline. I can schedule this to run every night at 12 a.m. and my executive's dashboard is going to be refreshed with their top 25 on a daily basis every day. And that was my ultimate goal, and I wanted to be able to do that again on my own in a matter of minutes without having to open a ticket and wait for my data engineering team to get me that information, right? So that concludes my demonstration. Please contact Prophecy if you have any questions or would like to have a more deeper discussion. Thank you.
Cool. Yeah. So you saw that how we are using the Copilot capabilities of the Prophecy to expedite the entire pipeline development process. And you also saw that we are not abstracting anything from the user. Whatever you are writing, you are able to see and execute it. And yeah, we are working on few more exciting development where why to even feed things one by one to Copilot, why not to have a templatized BRE itself and feed it to the Copilot and it will generate your pipeline. So these are the few exciting developments we are working on. So yeah, this is pretty much I had to present about Prophecy. And yeah, I would like ask if you want to play around it. We have a 21-day free trial version of it available. You can register for it. and you can try on your own how prophecy looks like, and maybe some of your use cases might fit in into that one. So would be a good platform for you and your data team for sure. Thank you, everyone. Yeah. Anyone, I forgot to, anyone having any question, feel free to ask, else I am here till evening. Maybe you want to connect later. Yeah. So self-healing as in, I mean, can you explain a bit more?
In case there are changes to the data, right?
Okay.
So will it automatically detect and correct the pipeline, or should I go and...
metadata related changes it will identify, because once you create the gems or something, right, the compilation happens, right? So it identifies whatever, let's say you have made some schema changes, right?
Yeah.
So it will definitely figure that out, and maybe the forward gems, you have dropped some column, now it is not there in your source, so it will definitely start giving error on your UI itself. You can look into it and you can fix it then.
Okay, thank you. And second thing, I think you're publishing it to the, you're taking it to a level of where you're creating insights, right, through the prompts, right?
Yeah.
So is it possible to, what are the other integrations that are available? I saw Tableau. Is there any other integrations that are available?
For Tableau and for like so far Tableau is there, because as I said in 4.0 we have focused more on the prophecy for analysts, so we are definitely bringing others as well. Target, I mean, it could be different warehouses, like you can write into different warehouses for, let's say, maybe on the reporting side and the notification, so email, SMTP and this Tableau as of now, but yeah, we are working on more as well.
Okay, thank you.
I understand that testing is a basically strategy, like for ETL. But is there any features that you are providing for testing?
For testing the data quality or the pipeline?
The pipeline.
Pipeline. So we can test the data, like we can write the unit test cases for that one to test it. But for the data qualities, we have built those gems itself, like using the open source library like PyDQ is there, and let's say Soda Cloud is also there for all that data quality checks and implementation. So we have implemented that one as well.
Thank you.
Yeah, so suppose I develop a workflow in Databricks, basically some pipeline. So is there any chance in your prophecy that I can just change it to a different tech stack and see the same flow?
Exactly.
Can we?
Like, yes, you simply, let's say earlier you build it on your Databricks, like that was your compute and all. Now you switch your environment, right? And maybe, let's say, select Airflow or anything as a orchestrated part. So as soon as you click on deploy, your whole pipeline goes there for the orchestration.
Oh, so the same logic, the code will change in the backend?
Yep, everything.
Oh, nice. So one more thing is, we write the actions, right? After writing the actions, if I click on the action, you are saying that we can see the code, underlying code.
Yeah, underlying
will
code.
I be able to edit the code if I want?
No, like you can first, let's say you can extract this whole code maybe in your GitHub. You can, let's say, do it there.
Outside the environment.
Yeah, you can, maybe you have a separate CI/CD and then shipping your pipeline somewhere. That you can do, but let's say you are changing something in the backend and you think that will reflect on front end, that won't happen.
Yeah, exactly. Like if I'm choosing some action, if I want to modify little things in that, I can't do it.
Yeah, let's say you have created your full-fledged version, now you're satisfied, just you have your code in your GitHub, just take a pull, just do whatever you want and have your CI/CD to do that.
Yeah, thank you.
I think just one more question if I can take a minute.
So you have provided a UI kind of thing to develop an end-to-end pipeline. And as a data engineer, we also write a pipeline, right, using the Python or any other scripts. So what is the advantage actually by developing through the Copilot? You are developing a pipeline, and if a developer write a pipeline, so what is the difference? What benefits we are getting from
manual effort? I mean, that time save part. I mean, if the Copilot, right, if I'm maybe spending 30 minutes to manually drag and drop every gem, configuring everything, and if Copilot can do it for me in 30 seconds. So I would prefer that one. I mean, that's what Copilot is bringing into the picture.
Okay, so will it understand the context of the things or whatever we will
Yeah,
tell
so
only
whole
that
pipeline metadata, it understands the whole pipeline metadata, like what UDFs you have created, what, let's say, data sets you have registered. So it gets all that metadata information, and based on your prompt, it will find that, okay, what data set I need to pick and what transformations, and it will build the pipeline.
Yeah, and I think you have already answered. Again, one question. Suppose in the source side, data source side, the data structure has changed.
Yep,
the
yep.
table structure has changed.
Yep.
So will it monitor that, or
Yeah,
how
so
it would be?
as soon as you come to like open your canvas itself, right, it does that compilation itself, right? It does not do it everything in the runtime, but compilation here, so it looks at the metadata of that table. If let's say later on, like maybe there was a column you have deleted, now it is not there in source, so it will instantly give the error on that gem itself that this is missing now.
One more question. It will work for all type of data sources like APIs,
Yes,
Splunk,
yes,
and
yes,
stuff?
yes, we have.
Yes. Thank you.
Cool, all right.
Check. Thank you so much, Shashank, for that wonderful session. I know there are many more questions you'd like to ask him. He's here till evening, so please do connect with him outside. Okay, I don't want to keep you all from lunch. Lunch is served. We'll take a quick break, and the next session will start sharp at 1:45, and we'll see you guys at 1:45. Thank you so much.
opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity, and optimizing every step of the process.
AI Run. It really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production. Writing test cases.
With clearer requirements, help us align our product roadmaps.
Instant market research.
To create stories.
Or rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained GenAI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product.
It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name. AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually a call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With IceDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. IceDQ, data reliability engineered.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MathCo from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity, and optimizing every step of the process.
AI Run. It really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
With clearer requirements, help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's better quality product, it's faster product.
It doesn't replace real humans, but allow us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name. AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually a call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, reducing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With IceDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. IceDQ, data reliability engineered.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligns with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
Check, check. Okay. I hope we all had a good lunch. I hope we're all energized for the next sessions for the evening. Again, a quick reminder, we have 2 halls, so please do ensure to check out the sessions in the other hall as well. And again, a quick reminder that we have something very special lined up for all of you at the end of the event with us today, so please stick with us. Okay, up next, we shift our focus from raw data to refined storytelling in the art of data publishing from noise to narrative. In this session, we will see the critical elements of turning complex data sets into impactful, engaging narratives. From selecting the right metrics to applying visual storytelling and context-driven publishing, this talk is about helping data professionals to go beyond dashboards and report to craft stories that inform and inspire action. To give us this session, we have with us Mr. Ravish Mishra, Vice President of Engineering Data at Angel One. With 2 decades of engineering experience, including 13 years in SaaS, Ravish brings deep expertise across data platforms, distributed systems, microservices, and platform engineering. A self-described full-stack engineer, he's led large, high-performing teams at Mindtickle and Angel One with a sharp focus on building scalable, interoperable systems that turn data into business value. Ladies and gentlemen, can we please have a huge round of applause for Ravish?
Hello. Can you guys hear me?
Could you check again?
Hello. Yeah. Okay. So thank you for taking the time to attend this session. I'm going to talk about data publishing, the data that flows through the state of the art architecture that we have now. Earlier, we started with data warehouses, then we started building the lakes, then we started building the lake houses, merging the data lake and the data warehouse, and now we have Gen AI that we can add to the AI stack. And at Angel, when we are working on to have an AI stack and the processes to build using Gen AI and related AI technologies. So there are 5 V's of big data, and all of us know about this, that volume, variety, and velocity. These are the 3 things that we have handled through the new architectures, the data lake house, or other architectures that we have, similar architectures. But the other 2 V's, the veracity of the data and the value of data is still questionable. How many of you are able to, basically everybody here should be a data engineer and they should be having a data platform in place. How many of you think that your organization is able to leverage the data to its full potential? If you have built something and you are able to tell stories that is actually driving business decisions, that is actually enhancing the customer experiences, then you have built a great data platform. So the volume of data is increasing at a very high rate. The global volume of data has increased by 5-fold in the last 5 years. So as we have more and more information, organizing it is a very important task. If we don't organize such a huge amount of data, we end up building a system that has information which is difficult to understand. Right? You cannot interpret it. The quality of the data is low. You cannot trust the data to drive business decisions. So there are types of noises in the data. For example, the quality of the data. Right? There are missing data. There are nulls. There are duplicates. Then there are measurements error also. So if you have worked on clickstream, I have personally faced this problem. when clickstream events had future timestamps, and that was, it took us some time to fix it, but these kind of errors are made when we actually start collecting the data. And when data is data, right? The moment you generate the data and you send it outside, right? It leaves the service boundary. The context of the data, right? The time context of the data is gone, right? Any data that leaves a service boundary, it is an information that has happened sometime, and when you receive it, you are looking at the past of some event, right? So again, right, if I look at the noise that we have in the data now, there is semantic noise also. There is disagreement between different departments on the definition of the same metrics. Customer is something for some department and something else for some other department. Another personal, I mean, at Angel One, there is something called activation. So Angel One is one of the top fintech firms in India, and we support broking services also. So what happens is, a client has to become trade ready. So there is a business metric called activation when a customer transacts for the first time. So there are multiple definitions for this, right? For example, we struggled for some time whether first trade is activation or the first three trades is activation. So some departments are tracking first three trades, some departments are tracking the first trade. So this is the semantic noise that we have in the data. Okay, temporal noise, data is coming at different speed from different systems, right? Temporal is, there is one more thing that I want to talk about temporal, and we will talk about it later when we go deeper into the conversation. So structural noise is the schema drift that we have, right? There is a mix-up in the same information. Aggregate information is also there, and granular information is also there. So when you process the data, the numbers are skewed. Right? Now, I have talked about noise. The real value of the data is unlocked when we are actually able to make decisions, right? The data, we have encoded the decisions in the data model itself. We should go towards that. When you look at the data and you have the decision, if you want to go deeper and understand why have the system made this decision, then there should be narratives that you can go through and understand how we have reached to a particular score or a particular decision. We'll look into the case studies also. One case study also where we'll take an example of data narratives. So again, right, the models that we have right now in, say, the medallion architecture that we end up building on the data lake. So the gold layer, we usually end up building the dimensional model. If you have really worked into the model, then it is dimensional model. Otherwise, there are only tables. You just aggregate something, build flat structures, the cardinality is very high, querying performance goes for a toss. All these things happen. But if you have really cared for what you want to do, you must have built a dimensional model and cubes on top of that. But even dimensional model it facilitates the querying. It is easy to understand and query, but the interpretation, the narrative is still left to the analyst who's using the dimensional model to tell the stories. Right? Data is an afterthought, which means that when we start building a business process, suppose you are building a feature and you are defining a set of steps that the customer has to execute and accomplish a goal. If you don't think about how are you going to measure the effectiveness of this business process, the set of steps that you are designing in the feature, if you don't think when you are designing it, when you are conceiving it, and then what happens is at some later time, the team realizes that, oh, we want to measure this particular event also. So then they go and instrument later after releasing the feature. So what happens is we don't get the full picture, right? Whether the feature is performing better, how can we enhance the overall business process using analytics, right? So this was just one example. Again, since we implement business logic in the gold layer, the business logic is replicated, right? So you have to maintain business logic in the source and in the gold layer. Again, this is an anti-pattern, and anyone who knows about the Dye principle, it violates it, right? So what we are going to do is we are going to discuss an approach, and I would like to exchange ideas. What do you think? How can we do it? But I have my opinion, I am sharing it here. So eliminating the noise, we are now going to eliminate the noise, and we are going to build the narrative, right? So basically enhance the data model so that narratives can be supported. So in 2011, I was working with a company that was building a product that they now call a data product. So the company's name was Mobstack, and what they were building, it is now known as Unicode. It is a QR code platform. They are doing pretty well now. So at that time, what they were building is mobile was proliferating, and everyone was accessing content, media content on mobiles. So what happened that all these media houses, right, the Times of India, the Business Line, everybody was trying to create an online presence. And they were not ready for infrastructure that could support mobile devices. So Mobstack created a system that could render the content on a range of like thousands of types of mobile devices. This was our IP. So what they did is they started, so these media houses, they exposed their RSS feeds, and we processed the RSS feeds. We had put together a parallel processing architecture that processed these RSS feeds and saved the information in the data structures that we had defined. Now, when I think about it, why did it work at that time, right? And recently, a couple of years ago, data mesh was made popular, and now I think it is quite popular now. There was a huge talk around data mesh, and I was lucky to get a chance to execute a data mesh also. And when I look back at my experience at Mobstack, I see that it worked because RSS feed was structured, right? The data was mutable, the contract was fixed. Anybody who is reading the RSS content, they will get the same information. Nobody gets a different view of the same information, right? Again, right, there were SLAs. I want to talk about immutability and stable events and the semantic layer. So any data, right, suppose there is an e-commerce system, right, and you order. When you order and write to the read model, when the order is created, you might have two tables if you have normalized it properly. There could be a item table where you have all the items, and there could be a order table, right? You have split the data into two tables. Now imagine that you are replicating these two tables in your data lake, and you are trying to recreate the order create event. What will happen? Do you think the state of order table and order item table will be same when you are trying to join, right? It won't be same, right? Because tables are coming at different speed, there is eventual consistency. The temporal context of the event is split and lost. This is the temporal content I wanted to discuss in the first slide. So stability is basically, so that's why first thing is we need proper events that have all the context, right? That's why we talked about fixed contract. We are talking about the SLA, that we know exactly what will be received, what may not be received, and we provision for that, right? Plus the data freshness and all those things are very important when we process the data. Immutability is very important the moment you publish the data, because any secondary service that is consuming from the primary, right, their goal is to build on top of it. They cannot change anything in the data that primary published, because the reality was encapsulated by the primary, right? You cannot go and change it later, right? Because then you will twist the reality of the event when it happened, right? So whenever an event is published outside the primary, it should always be immutable. Nobody should be able to change it. The moment you mutate it, you lose the context, right? The data is corrupted. The second thing is stable events, right? The information, the context that is passed, right, to any event when you publish the event, it should be consistent at later point of time also, right? For example, one of the examples that we can talk about is, for example, so I read it. So this President Bush, right? When we talk about Bush, it was different in 90s and it was different in early 2000s, right? The context, the stability is different, right? So it is very important that the context is passed in such a way that we exactly know what this is. There is no ambiguity in the event, right? The semantic layer is there is a lot of information in the events. You should be able to interpret it. If we leave it to the interpretation of the consumer, everybody will interpret it in a different way. So we need a semantic layer that clearly defines what is the event, what are the different fields, and what do they mean actually. So with that, I have since I have worked on the data mesh also. This is the model we implemented. Okay, what we did is we said that domain events should be published by the service, right? And how do they publish? Using the transactional outbox pattern. Transactional outbox pattern is a design pattern that you can implement on the databases. What it does is when you write to the database, you write to your read model, and you write to the outbox table, and you write the whole event to the outbox table, right? And since we are building the fact tables in our data lake or whatever system we are using for big data processing, we consume this event to create an append-only fact table. So for example, order created can be order table and order item table in the read data model, but there will be a domain event. If you are familiar with domain-driven design, it will be a domain event that will have all the related context, and it will be written to the transactional outbox, and we consume it from there. And we can use CDC or batch processing to tune in the evolving dimensions, basically the slowly changing dimensions. So this is the model that it has worked beautifully for us. So when I talk about the source-oriented data product, the aggregate data product, and the consumer-aggregated and consumer-oriented data product. So what is source-oriented data product? For example, I have a service, right? Order management service. I will have a set of cohesive events that are related to my that are relevant to order management service. So I create those events and publish them as a product, as a set on the data platform. This is owned by the domain team. They own this. Now I want to, for example, suppose I have order events in the source-oriented. Now I want to know daily orders, weekly orders, the trends and all. Then we go and create aggregate data products, right? Consumer-oriented data product is something where we start building the recipes, right? So where we actually join different things and create something that is very specific, right? An example could be that I want to build a data product that can give me intelligence on basically intelligence about the user's location and inference that I can draw based on the user location. So basically, location data is used to qualify people, say for loans, right? This could be one of the use cases. So we have to build such narratives in the consumer-oriented data products. So these are the concepts that are taken from the principles of data mesh. So basically what we are doing is we are differentiating between the data on the inside, the data that is used to manage the state of an application, that is data on the inside, the data that is published, right? so that you give commands to other service, and other service might want to building intelligence on top of the board layers that you already have is the key to unlocking value and basically reducing the time to value. Velocity of data is very important so that you can change your narrative based on what is happening in the source, in the primary, how the user is doing. Is there a new event that affects loan eligibility? Then it should not be delayed. Otherwise, we will end up disbursing loan to someone who should not get the loan. So yeah, that's all from my side. We have 5 minutes. We can talk.
Yeah.
Yeah. Okay, so let's talk about business process. For example, when you land on Angel One, for example, a broking platform, you have to complete the KYC. You are a new customer, right? So what happens is you have to go through a series of steps to complete your KYC, to provide information, and you become trade ready. Now you are able to trade. We need some approvals from the exchange also. Okay, so what I'm trying to say, in the whole process you can do two things. You can either publish all the tables that you have created in your database, or you can create the event. Basically any user will perform a set of steps. So basically I have created my profile, right? So profile created, user created is one event, right? Then user has provided its say address proof, that is another event, right? Then the user has provided his identity proof of identity. So all these are events in the process. Whatever the user is doing, right, you want to measure it, whether this particular step is effective or not. Is the user able to successfully upload information or give us the information on we are losing a lot of user at this point in the funnel, right? So what we are, by domain event, what we want to say is whenever user is created, whenever an order is created, a lot of information is there in the actual event. When you push information through an API, right? The API has all the line items, it has a lot of timestamp, it has order details. So, but that information is split into the tables when you actually write it. So what a domain event will be using that full response, the whole context that you extract when the actual event happened, right? When the client actually placed the order, you encapsulate everything and then you publish that. That is a domain event.
No, I was asking about domain ownership.
Domain ownership is, I missed it. Domain ownership is that the team, right, who is building the service, they own this event, they publish this event, they take the ownership. We are not joining everything and recreating the event in the data platform. It is joined and created in the service itself. It is shift left. That is domain ownership.
Thank you.
Do we have any other questions? Yeah, there's one. You can take the mic, please.
Is it on? So the question is like, you mentioned a very valid point that data should, come up with a narrative, right? And at least it should lead to a narrative. One of the catch situations is like engineers are not very good, maybe with that domain, or maybe they don't have the domain expertise. And those who have the domain expertise, they themselves at times do not know what is the narrative that would be the most compelling. So how can we bridge this gap? And are engineers also expected to understand the business domain itself to be able to build a correct, to be able to build a compelling narrative?
Okay.
Thank you.
Okay, look, the data engineering team is a platform team. And when you build platform, the expectation is that you are an engineering team and you do not really need to understand all the domains who use your platform, right? So look, the idea is that they should not need to understand, and that's why we are doing shift left. We are asking the domain teams to take the ownership, have the full domain related coding in the service itself, and then publish the event. And when we build the top two layer, the intelligent layer, the data products, we again need we need a product manager who will work with us and create those. So one of the problems that teams who have built a medallion architecture in the data lake, they face this problem that they are not able to build an effective gold layer. So what is needed here is that the data engineering team manages and owns the bronze and silver layer, but the ownership of the gold layer goes to the analytics team. But analytics team often does not have the skill to build the dimensional model, and this is a huge gap, and that's why building an effective data lake is very, very difficult. So if you build with such philosophy that you delegate the building of gold layer to the analytics team and they are responsible for building the dimensional model, then it will actually start working. I hope I answered your question.
So we are unfortunately out of time. If you have more questions, you can connect with him outside. Yes, thank you, Ravish.
Thank you.
Thank you, Ravish, for that insightful session, and thank you, Anshika, for hosting the first half of the day. I'm Vandana Nair. I'm a senior tech journalist at AI Media House, and I'll be the host for the rest of the day. So quickly moving on to the next session. The next session looks at how AI is influencing the field of data engineering, from automated pipelines and anomaly detection to natural language interfaces and synthetic data. As the boundaries between traditional engineering and intelligent systems continue to blur, it's becoming important to understand how these tools are actually being implemented on the ground. We'll hear all about the emerging trends shaping this space and how they're impacting everything from real-time processing to governance and compliance. So to do this, please welcome the head of data and AI platforms and engineering at PharmEasy, Ramesh Kumar Saxena.
Hello, everyone. Thanks for joining. So, so as the topic suggests, right, emerging trends in data engineering with AI. So I will take you through, like, this will be agenda for next 30 minutes and so, and if we have time, we can have question and answers. So we'll start with the data platform architecture, and most of you will be familiar with that. Then we'll go over what are the challenges with the traditional data engineering teams, right? All of us most of you comes from data engineering background, and you must be knowing all those things. And we'll talk about some of the things that we have solved at PharmEasy using AI. And then we'll talk more details about what are the emerging trends. Okay, so I mean, this is the architecture that most of you are familiar, right? Now, on the left-hand side, you have source systems, be it from RDBMS, NoSQL, any file systems. You can have data from your REST APIs, or you can do the event ingestions, right? Be it clickstream events and all. And then in the middle, you'll have what we call it extraction or ingestion layer. I mean, this is our architecture, so somebody maybe put a Kafka or maybe directly load to your data warehouse or something, right? And in between, you will have the transformation layer, right? I mean, and you manage through some workflow, let's say Airflow or any other engine that you have somebody, and you do the data cataloging or maybe self-service part of that, right? So, I mean, if you see these architectures, this has been working for ages. Obviously, data warehouse was there from the days. It has changed to new things called BigQuery or something else, right? And many things has come, right? In open source, we have high Presto query engine on top of it. But underlying things are not changing, to be honest, with the AI. What the problem that let's talk about few challenges that all of us face when we looked into AI world, right? And how AI is solving that problem of data engineering, right? So I think many of the sessions already happen in the morning, and you must be knowing that there are a lot of product available in the market. But I will not get into any product-specific problems and all, but let's talk about the problems that you see, right? So starting from your sourcing layer, which is the data ingestion layer, right? The problem, if most of you see, right, source systems have changed some schema, and it has gone to your Analytics team is saying that everything is broken, I'm not getting the data log. So obviously there is a data latency on that because the pipeline is broken. It could happen like in between, like you have, if you see my architecture, we have multiple components, right? It could be Maxwell, Debigium, which we use for CDC. There could be a problem in that systems because there could be huge lag or something. If you're using Spark for your loading data log, there also could be some problem in that, right? So latency, your data latency could be a problem because the analytics expects some certain point of time the data should go. Same thing can happen in your Kafka layer, like let's say some rebalancing is happening and your data is not at, like, right? On the right-hand side, while you're loading the data, let's say we use Apache Hudi, but if you're using any of the Delta Lake format, there could be schema is evolving over the time, and there could be problem in that, right? Now, and most of the times, like we have facing this, like all our data engineers are sitting around the corners to solve these problems. And I will see that, how we have solved this problem. So I just wanted to be more particular on the problem that we are trying to solve. So I'm just, whatever I talked, I have just listed, right? We have reactive monitoring when something is caught after, let's say, analytics has, or any other downstream system has complained the data is not available, right? You have manual data quality checks, like from the source to your destination, you have some data quality checks, but they are manually, right? From the time to detections to time to resolution, it takes some time, right? I have working with a big company like Walmart, I have seen that it goes in multiple days to fix those issues. So how do you have a faster issue resolutions, right? Then how do you scale your data platform? Like let's say, I talk example of Walmart and even with my current company, Pharmacy, like let's say new source is being added, right? How quickly you can give the data to your consumers, right? It takes like setting up the pipelines, engineer has to set the pipelines, create those transformations or load the data, right? It takes days. How do you make sure that if new systems are getting added and new pipelines are added, you are able to scale that, right? So these are some of the problems. And then the cost. So last 2 years, I'm working in Pharmacy to reduce the cost of the data that we had. And all of you must be working some way or others to reduce the cost of the pipeline. Like, how do you create this, right? These are some of the learnings that I have put it, and maybe you might have also encountered that. Coming back to, like, obviously the solution is to have proactive monitoring. How do you, like, so what we have done it like monitoring part. So right from your data comes from, let's say, Debigium, Maxwell, to your Kafka, to, let's say, Hudi data lake or something, and then the consumption layer can come. We have put all the, I could say, data instrumentation so that you get all the metadata associated with that, right? And then you publish to another Kafka topic, and you have a monitoring alerting based on AI. So AI can detect what are the anomalies on that. Like, let's say, some of the query is running for some, it's a small things, right? Some of the query which is getting the data from some systems is running for longer time. It can alert you that this can, it was working previously also, but AI is going to help you on that. Then we also have like automated data quality management, which basically like you have, let's say some field is null, or some values are not coming up properly. Manually you set up a rule, and then you go ahead and try to make sure that your rules are, your data is as per the rule, and if there is nothing, then you can show into dashboard. Now, that's one way of looking into it, but ideally, like data drift or any missing value outliers, all these are the problems that ML solves, right? Not only with the GenAI, but all the problems that we have been looking into, right? You see the patterns of your data. Let's say any data is getting ingested over time, or maybe there is anomalies on those patterns. So we have automated using some of the, what we call it MLDQ, and that has helped us to basically predict what can be future. Not only that, when the issue happens, let's say pipeline is coming, we have some time to react to it. That time only it says that your data is not as per that. Like suddenly the, let's say, volume of data has increased. There will be delay on the data side, so it can alert, and then you can take some level of corrective measures, right? I talked about like one of the problems, like when issue occurs, you take a lot of time to fix it, right? Why it is? Because you have to understand from where the data has come, right? It could be from the source system, your Debigium has some issues, or your Kafka has some issue, or your maybe while loading the data has an issue. So what we have built it like end-to-end data lineage. And not only data lineage, there are a lot of tools to build the data lineage, but what we have done it like we have powered with AI, which basically gives us what has gone wrong with that, right? It basically gives you like, if some problem has come, let's say it could be your SLMS, or it could be data quality issues, some values are missing, some data is not coming, it basically trace back to that component where is the issue. And it gives us an intelligent view of that. This work is still in progress, but we are able to solve that complete end-to-end using AI. Scalability, right? I talk about like pipeline takes a lot of time to create it. Like we have been solving this problem without AI also. Like we can create a self-service drag and drop, and basically you can have that end-to-end data pipeline created within few hours. But with the AI, like with the generative AI, like all this pipeline can be automated using some commands, right? And basically you have agentic frameworks in between which can orchestrate that and create you that. So we have been doing a lot of work on that, like because we work in multiple different companies. We have a group of companies, and each company has their own data needs. So what we're trying to do it like make sure that all the scalability of not only the pipeline, but even let's say you have to elastically scale all the auto scaling of those parameters, then we can configure it. And that will help us in maybe onboarding a pipeline from days to few hours. I can say that because our team has been working on it. Then last but not the least is the cost control, right? As I said, like there's a lot of learning on why the cost has increased in data pipelines, right? Many of you know that we say that distributed like S3 or any other systems like distributed file system is cheap, right? You just say that, but in practically, and at my level, like what I work in the group of companies, our S3 cost is the highest, more than the compute cost. And reason for it is like you don't know what data you are trying to ingest. Like one of the reasons that I will talk about is like there are so many versions of the data that you keep it, right? And S3 has something called versioning. So I know that this AI has come up with a lot of features which you can detect and see where is the data is going. Like let's say you have a versioning of the things, you understand whether it's a real data or it is just a copy of the data that you have. And that way, it has really helped us to control some of the cost feature. It has drastically reduced our cost. Like we have been able to, do that by finding some of the. So I'll talk about like all these are, I could say, AI has helped us in powering all these data pipeline in a better way. We are still work in progress on this area, but we have seen tremendous benefit of using all this AI capabilities to make sure that our pipeline are reliable, it works at lower cost, and we deliver to our end customer on right time, right? Now talking about like what are the key trends, right? Which we have been seeing and we have been applying. So I have put few points, and it's still evolving over time. I think some of the session was on this, right? I mean, data pipelines. One of the important part is your metadata, right? Like when I was with Walmart, I was working there on their data cataloging system. And believe me that it was a humongous task. So many data sets coming into picture and cataloging them was a big problem, right? Because let's say you have a table, thousands of tables, thousands of columns, how do you catalog? And make sure that they are accurate, right? Because as your source is being changed, your data, like your underlying metadata will be of no use if you don't update it, right? So that's the one problem. I think even Google and Microsoft, we have been working with them, like they have their own cataloging engine. But the problem with them also, like this has not been integrated on that. Some of the open source companies and all those has some power, like where you can use Gen AI to generate your metadata, right? So that your work, your engineers is not just plumbing that cataloging, but it automatically get generated. Not get only generated, but it get updated also over time so that your metadata is more clean, right? Related to that, like one of the things that we are heavily investing using AI is like self-service analytics, right? Which means like, I'll talk about details about this, but this is one of the area that we have been investing. Like users goes like, to a dashboard and they look into data and they try to, see what is the pattern on the data, and then try to get some level of understanding if something is going on. Like it could be a sales dashboard, it could be anything else. What we have powered using GenAI is like using text to SQL is like they can have story with their data, right? I think they can just ask the questions and they can answer those questions in plain English language, right? So that's the one of the, I think, heavy investment from my company on to make sure that business team is not depending on analytics to give them data. Like, they just works on like data, like which is basically they can self-serve, right? Then synthetic data generation is one of the problem, like, when you start doing your data pipeline, or any other ML training or testing, the problem is that where to get data, right? Your QA environment has very less data, right? Once you get into production, there is a huge problem that start coming up. Say, like, I was working with one of the financial companies. Everything was working in QA, but once we deploy into production, everything failed. The reason for it that we don't have the right kind of data that on which we have tested, right? With the generative AI, you can test this diverse set of data, right? Like, let's say, the problem for us was the skewness in data, right? Like US has more data than India or other companies. So you can create those and simulate your real-time data, not with the actual data, but with the synthetic data. This is one of the area that GenAI has been really helping us. Then, obviously, like, new branch of data to AI engineering is coming into picture. We'll talk about that, what is the AI engineering is all about, because now focus is shifting more from data engineering to AI engineering, where a lot of capabilities is being built using AI, right? So I talk about, like, Gen AI powered metadata management, what you need, like, So if you see in metadata, I think there are a lot of product outside market also, and I have seen from the companies, but ideally you need a metadata discovery to happen properly. Like, you have, let's say, a lot of data coming from different systems, like from MySQL to Postgres to your NoSQL to your file systems to anything else, right? Now, the problem, like, and if you are a company like Walmart or JP Morgan or any other companies, there is a huge set of data that is getting generated, right? Now, how do you have algorithms to basically scan those data systems and make sure that, like, your metadata is updated and with the meaningful insight to it, right? So when I was in Walmart, there was a big team called data stewards whose job was to just scan the data and just put the meaningful name to that data, right? Now, with the Gen AI coming into picture, obviously the data stewards is required, but a lot of plumbing work, this looking into table and column, you can say what is there. And then it has the contextual data to it, right? So we can automatically discover the data, scan through that, and create all those, like the metadata could be technical, operational, or business metadata, right? So it requires, like, so data tagging is one of the important part, right? For how you can, do that. And the classification of your data, right? This is another problem, like if you are going to scale, right? How do you enrich your data, like say whether it's classifying in the sense either sensitive data. I work with the healthcare system, so there are a lot of PHI data coming into picture, right? Like let's say your diagnostic report comes from ThyroCare, you are uploading your prescriptions. So there are a lot of data that comes into systems, and we have to automatically classify because we have millions of such data, right? And anywhere in the systems, if you have those things, then you have to classify and say that which data is done. GenAI help us on some part of it. Still, this is a problem because once you try to classify your data, like, you have to scan the data, right? And your cost may get increased, so there could be some accuracy on problems, right? Then I talk about data lineage part. So data lineage, another problem that we have from end source system to your data lake. There is a lot of, metadata get generated, and how do you stitch, like from this table, this column is transformed from that different table and different columns, right? And if you have multiple layer of transformation, you can think your life is going to be hell. So how do you make sure that taking those instrumentation by AI agents and basically stitch together so that there is accuracy on it and it is more reliable also. So, and then one part of, like, we work in a lot of search and recommendation systems, right? And this, let's say you do a search in Pharmacy app, right? And the search result did not come, right? And there is a lot of contextual metadata that has come, like which user, what time, when, and where, right? And so these are the contextual data sets which we can join and get the meaningful insight to the business that this could have been some problem. So we have been playing with this metadata generations using AI and lot, and it has helped us in a big way. Okay. Okay, now I was talking about one other capability that we have been investing on, text to SQL. So just to say the summary, what is a text to SQL is like, all of you must be knowing it, but it's just a plain English you write, and it gives you the data, right? I mean, still it is happening that you raise a request to analytics. So business folks raise a request to analytics. He writes a SQL. It's validate the SQL, then execute the SQL, and then it gives it. Like during this time, it takes 2 to 3 days, right? No, I mean, because somebody has to, and there is a back and forth. Maybe the business person didn't ask that question, he has generated something else. Then again, he has to go and correct back his SQL and give it back, right? It is very common problem everywhere. What we have been doing it, and we are piloting this with different teams, and making sure, like, you know, like all those questions that like business has a frequent asked questions or any other questions that come related to data is in plain English format, right? Like, I just give an example, show me a total sales of top 5 product in last 7 days by region, right? And they'll just provide that and they will get the data, right? And we have been exposing a lot of chatbot interface where they can just try to do that. Obviously, the governance process has been inbuilt because we don't want like right persons to have right access to data, because this text to SQL can be abused. So maybe we make sure that all the governance process and everything is taken care, right? So that's the another area that we have been heavily investing. And I'd like to show demo, but I think it's not working. Another problem that I talk about the synthetic data, right? You know, so synthetic data, as you know, right? You know, you can mimic your problems, like all your data, like whatever could be, right? It could be. I give an example, like, you know, a bank wants to generate a credit card transactions, right? He cannot create a credit card transaction just on the fly. So maybe with the synthetic data, he can use those credit card, fictitious credit card with that validation inbuilt and create a customer records on top of it, right? Without using the actual customer records, because there could be a lot of challenges on accessing those PII information that that has. Like, so synthetic data has been helping us, like, in our case also, like, we have a lot of prescription, test report, and there are different variation of test report, right? So without actually getting the test report, we basically, let's say you go for HbA1c or any other test parameters, we know these are the parameters, this could be the actual range, and we generate to see how our, you know, all our analytics pipelines works on that, right? So, and then you don't require a real data. Once the real data comes, everything should work if you have synthesized your data properly, right? Now, last, I wanted to talk about the AI engineering, right? You know, which again, we have extended our team, which is data teams, to now AI engineering team, which basically, like, we have, as you know, all of you know, there is a LLM models or generative AI models, and then you have the models which basically, like, all the workflow or API that is built on top of it, right? Like, let's say I talk about text to SQL, right? So think about like text to SQL, there is a LLM for it, but for like, to, let's say user gives a plain English language, right? And it has to finally show a dashboard or a report data to him. In between, it's not just the LLM that does the job. There's a lot of work that have, first the request has to go through a REST API endpoint, and that REST endpoint will call your LLM models. It could, like, you know, maybe in our case, we are using, let's say, Gemini or any of the other things. You can use ChatGPT. But a lot of prompt has to be provided, right? There's a prompt engineering part of it, right? Because text to SQL, finally, how it works, that if you show those metadata has to be stitched together in the background, and that data basically finally converts to a SQL. So let's say I say cells, that cells has to be going to a corresponding tables, right? And then that table has reference to it. So all of this has a lot of engineering overhead, I could say, right? You know, and unless you take care of that, even how powerful your LLM is there, that is not going to work. Like, and the pipeline aspect of this, like, you know, so I have, let's say, text to SQL, but it is as good as your data set as the end, right? So let's say data model is that. So we make sure that quality of those data on which the text to SQL runs is very good, right? So there is a lot of data engineering comes into that. Then we have RAG and agents, right? So agenting is like we have used some of the open source agents, and we build on top of that a chatbot, which is basically like, let's say, a customer support comes into picture, right? So, I mean, and this is a famous use case, like, usually customer support comes and say that where is my order, right? And that order basically like shows that you are stuck into this place, right? And they have the follow-up question on it, right? Right now, if you go to our dashboard, it will just show that your order is shipped or not shipped, right? But if you have more contextual question, is that when it was shipped, why it was delayed, it can answer, this chatbot can answer those questions. And that's why like all this like AI engineering is helping us, right? Whatever AI platform is helping. So obviously we use Gemini, but all these AI platforms is helping us to make sure that all the plumbing works has to be done to work with the chatbot is done, right? Then same thing with we have our own vector DB, like all the and that has to be managed with all the by the data engineers to make sure that they are scalable, right? We do like a lot of fine tuning. So obviously we have an inference optimizations, like you have a pre-trained on AI model like ChatGPT or your Gemini, but we do a lot of fine tuning on customization on that. And similarly on the, let's say, initially when we started using the Gemini model, it was very small, right? But very latency was very, you fire a query, it goes and then come back with a lot of things because the context to them is not correct, right? So we have contextualized and make sure that they are fine-tuned, and we did the inference optimization also. Once it is, inference optimization is nothing but like you basically get the data in a format and then make sure that it has the low latency to serve to your API that is asking for, right? So, and then we build all this AI observability and explainability platform, which basically means like, let's say, I just talk about the same text to SQL use case, right? Now, it gives you data, but it doesn't explain where this data has come from, right? So we have built that explainability. User can go and see this data is belong to this table, or maybe it gives the SQL also for a technical users, but it also gives the reasoning of that, right? How this data has been derived. So if I have a ThyroCare cells, it says that from the ThyroCare, from this region to that region, I have joined this table to give this data, right? So it gives us complete explainability so that the user has trust on data, whether it's great, good or bad, right? And that's why this platform that what we call it AI engineering or AI platform has been helping us. I think this was the last slide, right? So in summary, I think I talked about from the source to destination, right? I mean, when we started, it was more like traditional data platform and things like that, right? Because as I said, like, we first build those platforms. Now, with the Gen AI capabilities, like we have plug-in everywhere, right? Right from data observability platform, which is detecting your pipeline failures, to remediating those failures. Now, putting the data in a way that, you can have more resilient system. It like if something fails, we have more resiliency to, take care of it. And finally, on the consumption side, we have using the text to SQL to make sure that our business has integrated, experience and more self-service experience rather than, depending on analytics. So right from ingestion to insight generations to operational intelligence, we have been using AI. I'm happy to have more deep dive conversation if you guys have any. So next, any questions? Yeah, please.
So on your last part, right, the chatbot-based data analysis, text to SQL, what you are saying. So just wanted to understand the level of maturity you have, like, and what's the success rate, right? Because for companies who are very young, right, the first problem we find, as soon as you roll out such feature, like, people will try to break it. Everyone loves that, right?
Yeah.
Oh, it's not working, right? And then it goes away. So how do you reach that path? I think you're pretty matured. You're saying even the customers are using your chatbots, right? Then that means you're very confident about it.
Yeah, so I'll elaborate on this part. Like when you talk about, I think you're talking about the accuracy and confidence on that. Like, and this is an open thing. Like text to SQL is, and if you're playing with some data, it has to be accurate. So the problem with how we have approached, and I'll give some of the best practice of the text to SQL. Like, if you have too many join condition in text to SQL, it is going to want to fail, right? Because that's not their job to have 600 tables joining together. You have to limit the tables to join. Let's say we have limit to maximum 10 tables. And also the accuracy comes that, as you said, like, the first part of the text to SQL was the metadata generation. So initially it was very bad, as you said, like everything was failing. If I give, India region, it takes Tanzania, right? So it doesn't understand what the region means. Let's say even for sales, let's say I say SKU. SKU doesn't understand what the SKU means, right? Obviously LLM is getting powerful, but we have to explain it. Like if I say financial year FY, something like that. So there are a lot of metadata enrichment happens. So to answer your question, it is not the text to SQL or LLM capabilities, right? It is all about how you enrich your metadata, right? And you make sure that you limit those table to few tables, and those tables, each and every column has to be explained. It is a learning process. I'll say that, first time it will not be right, but once you do continuous improvement on that, it will be right. So right now, I'll just say yesterday example, I was showing the demo. So there was a dashboard where the some number was there, and text to SQL has some the number. So your point is that just to blame the text to SQL, but in fact text to SQL was accurate than your dashboard. Because the problem was the dashboard also can go wrong because they also depend on some filter conditions and all. The reason for it is like we have very enriched metadata, we have very contextual information of the data, and we give the limited data. If you give the world data, if you try to do into ChatGPT, it will give you some random SQL. But it gives me like even the join conditions. I wanted to source, but I think that laptop is not working. But basically, it gives you all the group conditions, where conditions, and join conditions perfectly well. And if you limit your data to a limited data set, LLM is very powerful in that sense. Hope your answer.
That's insightful. Thank you so much.
Hi, Ramesh.
Yeah.
Anubhav this side.
Yeah.
Hi. My question is around text to SQL only.
Yes.
I wanted to understand whatever systems you have put into production as of now for NL to SQL. What was the user experience for it? Was it a chatbot kind of experience with a bunch of different user experience around it? Maybe because the way I think is a user might be interested in seeing a visualization based on whatever he queried, or he might be interested in getting the data itself out. For example, give me the last 10 customers who bought something on my website, something like that.
Yes.
So what, especially speaking about the thing that went into production.
Yeah, so good question. I think what we do it like we take the first cut, what we call it MVP, and we take a lot of user feedback. And we learn from that. So as you said, first version that we were not knowing that what kind of query that he will put. Like I was just talking about SKU, FY, some random things was coming in his mind and he's putting it, right? So experience-wise, it is a continuous journey of any like text to SQL journey will happen, right? Part of questions that you are asking, like,
was it a multi-turn UI, chatbot UI kind of?
Yeah. So I will just coming to that. So we have both interface. So we have a standalone UI which we build with the open source Streamlit. Streamlit is a open source engine, right? So we have built, and it has a conversational history also. So basically like similar to ChatGPT that you see, right? On the left, whatever you have answered your question in the past, last, whatever. So it caches that data also, and also you can ask like a conversational way. So let's say I say, give me revenue for FY 24-25. Then I go month-wise, and I'll drill down into a particular region. So you don't have to like just give once, and then you can have a conversation with that data. So that's our, obviously that was the one of the feedback. Initially version doesn't have that, but later on we found that this chatbot experience was more better because dashboard also gives one way, right? Because there is a lot of chart, and you can have to drill down and do that. But here they can ask questions and give it. But there is a cost to attach to it. How much tokens per se you put it, because there could be a lot of long chat history coming into pictures, and there's a cost associated. So you have to take the trade-off. We also optimize that token per chat, how much you can, because it can be abused, so that our cost does not increase. So we have both interface as a UI interface, a standalone UI where they can go, and we also integrated with our chatbot framework where they can ask these questions in a conversational way. Hope that answers.
Thank you. Thank you.
Sorry, we're out of time.
I'm here, we can ask you.
Yeah, you're outside, right? Like, if anyone has further questions, can connect with Ramesh. Thank you so much. Can we have a big round of applause? like to go on to the next session. Data alone doesn't create impact. It's what organizations do with that drives outcomes. The next session explores what it takes to shift from passive data collection to actively using data to influence business strategy and performance. We'll hear about key pillars that support this transformation, including how to align data teams with business goals, avoid common pitfalls like siloed structures, and build a culture that supports experimentation and predictive insights. Can we please welcome the Chief Data Officer and Head of Insights Business at PayU, Kaushik Kadidal. Please, can we have a big round of applause?
Good. All right, can you all hear me? Perfect. So, good afternoon, everybody. I know there's like 2 days of session here, right? A lot of conversations on data and the latest in technology and the direction that we're going with Gen AI and all of that, right? I'm probably the only speaker that's not going to talk about technology, right? I'm here to talk about something that's next level, right? Which is how do you drive business impact from data, right? Because at the end of the day, we are only as good as the business impact we drive, and oftentimes the two of them are not necessarily correlated. So that's what I'm here to talk about. And feel free to stop me. I'm okay with questions along the way. Let's see if this works. Okay. So I'm going to start with, there are two components to drive business impact from data, right? What you have on the left-hand side is the technical capability, right? In any organization or for any individual, right? You need to have the technical capability to be able to drive your data agenda forward. And that is what the 2 days here is going to be, and that's what I'm assuming 98% of what each of you spend your time on is, right? But there is something on the right-hand side, which is the DNA of an org, or really the DNA of a data professional, that is something that's overlooked often, particularly in the India context. We overlook it, and that's, to me, that's a differentiator between having a good company versus a great company, or a good data career versus a great data career, right? So, like tech plus data DNA is really where the value is, right? Like just to sort of give you a little bit of a background for myself, I was born and raised in Bangalore, and then I went to the US, did my MBA, then worked for Capital One, and between that I did my GMP at Harvard Business School. 15 years at Capital One. I don't know how many of you know Capital One, but Capital One is the only bank in the world to this day, as far as I know, where the P&L is owned by the data function. The bank went IPO in '94, and at that point, it was like a really teeny company, which today you can say a fintech, and that was before the term fintech was coined. And they were competing against the Citibank and American Express of the world that had 200-year-old history. But in the next 10 years, from '95 to 2005, Capital One moved from being a small fintech startup, if you want to call it that, to being a top 10 bank in the US, all on the back of data. If you go read up it's a phenomenal story. Anybody in data should read about Capital One, because again, the company just tells you how data can be leveraged to compete in the market and win in the market, right? In a market as mature as the US, in 10 years, going from being like a startup to being top 10 is like a feat that nobody has achieved. And so I had the privilege of spending my first 15 years of my career there. And then I moved back to India and took a job at a GCC running a major, for a big bank, right? Like it hit me really hard. Like I'd never worked in India. I'd done my undergrad here, but didn't even do my master's, right? It hit me hard in many ways, right? Like you had the most brilliant analysts, you had the most brilliant data professionals, right, on any dimension, except one. They did not know how to think business. They did not know how to influence business. They did not know how to connect business to the data they were seeing. That just meant that, all of them was just going to spend the rest of their life providing data to somebody who makes the decision. And oftentimes, at least in that big bank, and I can tell you that's true for most of them, right? 8 of the 10 recommendations that went based on data did not see the light of the day. That's just like mind-boggling, right? You have the most talented people from a technical skill set standpoint, and then you have impact, which is like close to nothing, right? So, that's when it sort of hit me hard to say, okay, what's really going on here, right? Why is all of this not translating? And so what I'm going to share over the next 10, 15 minutes is my point of view on that, right? So if you're a founder or if you are a C-level person in an org, just take this as how do you set up your organization to actually let data give you a competitive advantage. If you are a professional, take this as what do you need to do to be able to go from a techie to the boardroom. So that's what the next few minutes are going to be about. So I'll sort of peel the onion a little bit, oversimplified, but I think that serves the purpose. I'm going to walk you through what in an organization or what in a person leads to driving the real impact, right? So first is the organization structure, right? So today I'm the Chief Data Officer for PayU, and I also have the data innovations business, which drives a third of the profits for PayU, right? So I'm one of the few people that has the geeky side with the data engineers and the data sciences, but also has a P&L, right? Like I was in Mumbai the last 3 days just meeting a bunch of banks trying to sell and stuff, right? So, exercising both sides. The key thing is organization structure, right? Oftentimes when I go talk to CDOs at bank, right, and I do a lot of that as part of my job, the thing that comes about is, you talk to them when you pitch, you're like, okay, look, this is the data we have and how you can use the data to further your business and all of that. And the CDO will talk to you, they engage you at an intellectual level, and then you leave the room, they say, okay, let me think about it, come back. A month later, follow-ups later, you're still not able to, get into the business, right? So when you go through this with multiple banks, what you realize is the CDO really doesn't have the influence in the org. They don't control the budget, they don't control the decision or the strategic direction. Because they have a big role. They sit horizontally where each of the businesses sort of come to them and say, I need this analytics done. Right? I need this data from your team. Right? Which then means that their influence is limited in the decision making. So if you again, like if you're setting up a company or if you're a C-level person, please make sure this is not happening in your organization, right? There's no point in really, really high-end, analytics and data sciences if you're not driving business decisions based on that. So make sure that your CDO is empowered and every single person on your data team is empowered. And if you happen to be working in a place where that is not true, build the skills to start thinking business and find a place where you are actually driving business impact, right? Because after a point, how much, the technical skills can only take you so far. Like then you really have to be able to drive the business impact and have a conversation with the CEO and, so this is one. So alignment of KPIs. Again, like I was at a big bank, running their captive analytics out of Bangalore. Large team, big dollars, lot of decks, lot of Excel, lot of architects and stuff. But end of the year, when it came time for my review, it was all about hey, did you bring in new techniques? Are you using the latest in data sciences? Is your partner in the US happy with you? Right? It was never about how many, like what is your dollar contribution this year? Right? And then I went one step further, right? Because like that's how I'm wired, and I was trained for many years. So I went one step further, and 1 year I kept the full log of every single thing my team did. And I said, look, year before this was the business impact. How many models were built? How many of them were implemented? And what was the impact of those decisions? And I kept a log of that. And then another year came, and time for self-appraisal. So I just said, you know what, I'm not going to write my self-appraisal. Here's a log, year over year. This is the business impact. I sent it to my boss and said, okay, and the boss was like the global head for the GCC, right? So the next meeting I had, the boss had read it and all of those. And then the feedback was like, this is all great, but it's business impact. Tell me how, for this center, how you have contributed, and like things like. Basically, that conversation led me to believe that the business impact wasn't really KPI for me nor my boss. Their KPIs or OKRs were very different. And that's when I pressed the eject button and said, okay, 6 months later, I was out of there, right? And like I said, I have a job where my evaluation is based on the business impact I'm driving, right? So that's another thing, right? You will, as a professional or an organization, you are going to do what you're asked to do or what you're measured on. In a lot of organizations, there is a disconnect between business impact and and your OKRs. If you're a data function, right? If you're on sales, that's different. That's all commission. Or if you're on the strategy team, that's different. But somehow people think data people is a cost center. They just sit there and they drive things, but not business outcome. If you're not driving business outcome, then you're wasting your time. Okay. So this is another one, right? Data versus intuition. Data is compass, right? Data does not lie. Data tells you what wins, what doesn't win. You do a test, you know if A is greater than B or B is greater than A. Right? So the problem is a lot of times data is used to prove a point, right? You could have some like the CMO in an organization and they think this product should be pitched, right? Then they're like, hey, we're thinking of pitching this product. Why don't you do some analysis, come back on if it makes sense, right? Guess what? If you go back and say it does not make sense, that's the end of your career, right? So being able to sort of, use your intuition and make data win over intuition, and building a culture where data wins over intuition is important. And it's very rare. But those few places where that is the case, you will see that the companies are growing at a very different rate, right? Another thing I'll say about this is, these days there's a lot of new algorithms, right, that can do very complex things. So oftentimes when I'm reviewing a model with my data scientists, what I find is they take the 2,000 features they have, they throw it into their cat boost, and they say, okay, I've built a model, right? And then you're like, this feature number 1, what's really the intuition behind it, right? Why is it giving you 30% of the information value? They're like, I don't really know, right? The machine told me that's the right metric, and therefore I put it there. Wrong answer. If you built a model and you're seeing something, you really have to be able to explain that with the intuition behind it for a few reasons. Reason number 1, the problem with predictive models is that it assumes the past is reflective of the future. 2008 financial crisis. It works until one day where it stops working. When it stops working, if you don't understand why that feature was there, your bank is going to go burst. And it happened. Many banks went burst, right? Even like for us, we saw, like, to give you an example, right? So like debt versus home equity, right, was a feature, which meant that if somebody has home equity, right, then you look at the ratio and you say, okay, more home equity is the safer the customer. But when the tides shifted, house prices dropped, home equity became negative, but the model still kept it and said that if you have more mortgage, it translates into a better this thing, but it flipped on the thing, and banks that were not able to catch it in time lost their shirts. That's why intuition is important, right? You cannot just blindly do that. So, and another thing is, most of the value is created from data, is created when you find a counterintuitive insight. I'm going to repeat that. Everybody has a world view. And that is the same for everybody, right? Because we all talk, we all say the same thing. But sometimes data will tell you something that's very different. 9 out of 10 times, the analyst that sees something that's counterintuitive discards it because it does not suit their worldview. But the one person or the one time that they go really deep to figure out what the hell is happening here, they come out with an insight that can really be the next S-curve in the growth of the company. I'll give you an example, right? So balance transfer, I don't know how many of you understand credit cards, but balance transfer is when you have loans on one credit card and then you transfer it to a different company, right? So let's say you are HDFC, you have an applicant, you could say, hey, if you have balances with other companies, let's say Axis Card, you move that balance into HDFC. The common thinking was, if a customer is already indebted and they're moving their balances to you, they are higher risk. Simple, right? Everybody operates with that assumption. Then one day an analyst, and this is real, right, from my Cap 1 days. One day an analyst finds that's not true. People who are doing balance transfers seem to be lower risk, right? Then, the culture of the organization started dug deeper and deeper. And finally they realized that is actually true. Because if a customer has, generally when people are applying for a credit card, particularly if you're operating in a subprime space, all of them have debt. It's not like somebody who doesn't have debt comes to you and applies, right? But certain customers want to transfer it to a lower rate because they intend to pay. There are other customers that do not intend to pay. They will not transfer the debt. They will get a new line from you. They will run up the line and then, say tata bye-bye. Example. And just on this counterintuitive insight that came from data, right? Capital One sort of ran with this for like 3 or 4 years and got huge market share. They got like assets from all the banks in the US, right? People, and they would approve people with a higher line when they were doing balance transfer and lower line, so people with lower line didn't come. So all the bad debts remained with the other issuers and the good debts came to Capital One. In the lending business, that's winning versus losing, right? So anyway, that's on data versus intuition. And then this is, again, like integrative thinking. Understanding the business is important. I cannot tell you even this to this day, right? When I talk to my data teams, they don't understand the business. You will have a data scientist from IIT, all like 8 years experience. They've built this really good collections model. Then I sit with them and say, have you been on a collections floor? The answer is no. Okay, you built this using the dependent variable of X. Explain to me why this is the real thing that the collections team needs from you, right? Are they looking for the model to drive efficiency or more collectability? oftentimes, it's like, deer struck by headlight, right? They're like a wrong question. You ask me about the K-square, you ask me about AUC, I'll answer all of those, right? With algorithm, backward propagation, all of that I can answer. But don't ask me why the business wants it, right? They gave me a requirement, I built a model, my model looks good, it's working, what's your problem, right? So like now when my teams, of course, there's reinforcement, and now they know that when they build a model, the first thing they'll do, they'll go sit and take a few collections calls, and then they build the model, which works much better than blindly throwing data at and building thing, right? So curiosity is super important. And this is in no particular order. So the last one I'll say is, like talent is important. If you work in an organization where the non-data people are not analytical, you're in the wrong place. They're never going to appreciate what you do. I'm not saying they should be all, engineers or, scientists or anything, but when you go to them and tell them that this is what you're finding, right? If the senior executive in the room cannot appreciate it, you're wasting your time. There are enough places, and you'll see, right? Successful companies versus not so successful companies. In successful companies, the average data IQ is much higher than in an unsuccessful company, right? So, and of course, when I do my, I'm sort of not unconventional in many regards, right? So when I do my interviews and my team hates me for it, I give a business case to a data scientist. Simple business case. And that you'll see how, first, in fact, now I've asked the recruiters to inform them that I'm going to give a business case, because earlier on, I'd give it, and they'll be like, I'm in the wrong interview or something, I'm like, no, you are joining a business. You're not joining a data function. First, it's a business. You're only as good as the business impact you can drive. Thank you, guys.
We're now open for questions. Yeah, can you please get the mic here?
Thank you, Kaushik. Very insightful. So this data engineering summit, I think most of the people are data engineer. And one problem I have seen in my career, it's about the impact you are saying, right? Totally agree. We should work with impact. Anything we are doing, right? Even small things we are doing in life should have an impact, right? But at times I've seen in data engineering especially, so this impact factor at times, it's mostly about empowering, right? The people who are doing something on the front end. So that impact factor goes away, at certain stage. How do you see data engineering basically? Okay, for analysts, makes sense, right? I can totally correlate. For data scientists, easy to explain, right? Don't understand business, it's not the right place for you. How do you see the data engineering? So people who are empowering all these things.
Okay.
Yeah.
So in my opinion, there's no function in an organization that doesn't directly connect with business outcome, right? So for example, if you are a data engineer and you're trying to move a process that has a 30-minute lag to near real time, right? You need to be able to put a business case for it, right? And say, okay, why am I really doing this? What is the business impact of doing this versus not doing it, right? But what I've seen is a lot of time, this resource was free, so this was a project on my queue, so I picked up that project, right? That's all fine, but when you pick up the project, at least have the curiosity to say what is the bottom line impact of this thing that I'm working on. If you actually go think and ask 2-3 levels of questions, pretty much every project that you will pick up within the data engineering function will have a economic value and a business impact, right? The motivation for your team should come from that and not from the fact that I'm working on something, not just from the fact that I'm working on something interesting.
So yeah, I mean, what I was trying to say, okay, OKRs are always there, right? For data engineering, we run through OKRs, right? There's an impact associated with it, but I see that fading away, like as you go down the line. So for directors, it's there, right? For managers, it's there. For leads, it's there. But as you go down the line, there are some people who are just executors. So is it okay? Like, is it?
In my opinion, it's not okay. See, it's a thinking. It is not about the day-to-day thing, right? Like if I'm working on something and I don't understand how this is helping the company, right? There's something missing. Right? Like the classical example. If I'm a janitor in a company, I can still say, how am I driving the business impact? Right? You can say, I'm keeping it clean so fewer people are falling sick, or I'm keeping it clean, therefore the morale is higher in the org. Right? You will be able to connect it, even a janitor can. So I don't have any data engineers can.
Get it. Okay. Thank you so much.
Other questions?
Anyone else? I think someone else had a question. No, all right. Yeah, I think we can wrap this session. Okay. Yeah, thank you, Kaushik.
Thanks a lot.
Please can we have a big round of applause? Moving on to our next session. As AI pushes the boundaries of what data can do, open table formats like Iceberg are reshaping how we build analytics pipelines in the cloud, delivering reliability, efficiency, and real-time readiness at scale. Today's session dives into how these advancements are empowering smarter, AI-driven decision-making. Guiding us through this transformation is someone who blends deep technical expertise with a passion for building meaningful solutions. With over 17 years of experience spanning roles from data analyst to architect, she has helped design and deliver complex data systems by combining tech with design thinking and agile principles. Please put your hands together to welcome Senior Solution Engineer at Snowflake, Sarita Priyadarshini.
You're going to have to put my presentation from there. Wait a minute. Just check. Is it coming? Good afternoon. Hi, good afternoon. Today we are going to, so you have had a couple of very nice technical sessions now. And honestly, the speaker before me, he was articulating the importance of, joining or connecting dots. I have worked with Apple for pretty a long time, and I have been a big fan of Mr. Steve Jobs. So I can tell you how important it is to connect those dots. So with that, I would again take a step back, completely into technology, and completely into a world where we are only dealing with data. What happens here? What you have seen, and this would definitely go on. So today we are talking about mastering the data engineering pipelines. Till now, until today, until you walked into the room, you have been processing data in a fashion where either there was an ETL, that is extraction, transformation, load, or an ELT, which is extraction, load, and transform. You knew about data warehousing. You know about data lakes now, but I want to take it one step further. What if there exists a world? What if data exists on your cloud service providers, whether it is AWS, Azure, GCP, or AliCloud, or any other entity that is sitting right on the bucket, and you would be able to analyze the data, read the data, process the data with any query engine? How would the story be? You do not need to. So I know the data engineering folks, I have been there in your shoes. I have spent a couple of, not couple, but many nights sleepless because the data doesn't match. The pipeline fails, and I get a Slack message, or I get a ping or something of that sort. And that is the life from where we are walking around, right? I'm not saying that that is something we are going to take away, but what I'm saying is we will have a different approach towards it, correct? So with that, this is what I meant to show you around. We have been talking about data, data lakes. We are talking about data warehouses. Just to take a step back, you all know about this, right? Data lakes, all kinds of data, structured, unstructured, all of it coming into the same space. You know about data warehouses, better models. You can build your analytics platforms right on top of it. And now we are talking about data lake houses and data lake analytics, where you are bringing in open structures, open table formats. In a couple of minutes, I'll show you, or I'm going to tell you what are these table formats and why open table formats. Already you must be aware of it. How many of you know about Hoodie as a table format, right? As soon as Cloudera came in, one of the first implementations which has happened, again, with a very large set of data. From there, we learned about Hadoop, how do we implement the same and then fine-tune it. From there, we walked a lot of our space. Oh, how do I do the ACID transactions? And I'll tell you today how we are going to build up the entire story, match them all up together so that we build a robust solution. So we came to the world of intersection with data lakehouse approach, right? So we are here having unified workloads. Very important is governance. Who, when, till what, right? Very, very important. Which data should someone see and which is the data that should be hidden? Very important for PII thing. Interoperable storage is what we have been talking about. And then comes schema on read or write. Okay, so this brings us, and this takes us to what are these table formats? What is the table format, first of all, and what is Apache Iceberg in the entire story of this data lake and lake house, and what is it that we are talking about here, right? So it's a way to organize your data sets, your files, right? And how do you do it? It looks like a single table. Even though your data, you must be aware of Oracle, you must be aware of those systems where you have got a table, you do a create table, and you write a statement, and your data remains on a particular tuple. From that day, that is one single row processing, we have walked a very long path towards getting columnar access of data, in-memory processing of data, SAP HANA, columnar processing of data, Vertica, Snowflake, and a lot of other providers who are actually processing your data faster, because we retrieve only columns, not the entire tuples in OLAP systems, that is online analytical processing systems. From there, we walk towards this architecture, where we are talking that there will be data sets, there will be files which are sitting in my buckets, and I would be looking at them like a table. It looks like a single table, but actually there are a lot of files which have been put together, right? It's not a new concept. That's why I asked you the question before, even before I started with this table format, and you know about it. We have been through the entire age of processing of data on these platforms, right? And this is all like Hadoop era, pre-Hadoop era also. This is something which has been existing. But then why the iceberg format, right? Even though the systems existed, and they were evidently used a lot, but there were a few sides to it, right? The downsides, like there were smaller updates, like if you want to do only smaller changes to your data set, that was something which got costlier. No ways to change in multiple partitions, across multiple partitions. You could not build a snap because they did not have the possibility of having a single snapshot of data, and they only had one layer of metadata on top of it. It is something which is written out here. All the directory listings which were needed for running the table for large tables took a very long time. And of course, we also had this physical layout of table, and Hive table statistics were often stale. So when you have stale statistics, what it means is that what is lying in your data is actually not the one which is visible to you. So it's similar to stale bread and similar to your data not being accessed in the right path, in the right pattern, right? So from there, what we did was we brought in multiple metadata files on top of your own document systems, and that is the basic difference in thought. And this is something which has been started by some of the engineers and very great names there, like Ryan from Netflix. There are other contributors like Apple. There are contributors like, of course, Snowflake. And I must tell you, how does it make an impact, right? I'll tell you how many Google queries today run on top of Google in one day. It is around 4.6 billion. And if I tell you that it is the same number of queries on enterprise data which are running on top of Snowflake today per day, and this is the amount of queries that we process. And this is the scale that we are talking about, right? So just again, connect the two dots here. We are talking about real contributions from real world users of very massive scales of data. So it is bound to be more, this is an open project also, because I'm saying it is open table format. It means that the contributors are continuously giving their updates, and they are keeping the systems up, tight, and really awesome. How does it look like? Just one or two slides around the same. How does it look like? As I told you, the metadata or multiple metadata files. This is something in the making, coming up, and it will knock on your door very, very soon. So let's look at it. I do not have much information out here, like right, left, all of that. But what I wanted to tell you was, there are a couple. Let's start from down, which is from below. There are a lot of data files which are actually getting stored. It could be Parquet files. Again, it is a format, table format. It compresses the data. It keeps it much, much sorted. Just like you have heard any CSV format, or we used to have Excel sheet format. So Parquet is also a format of table. Okay. So you have got a data files. On top of it, you have a manifest file. What does it mean? Nothing but a list of what are the data files which are lying within me. So it is class monitor 1. Okay. So it will tell you, okay, these are the number of students. I am the monitor. I see that these are the data which is coming up together. Next, on top of it, on the right side, if you see on your screen, you will see a manifest list. What does it mean? It is like, let us say, school monitor, right? It tells you that this manifest list has got these many manifest files which are again looking at the data files which are there in the list. This actually gives you a lot of flexibility, because you're not managing only one place metadata, but actually two layers of it. You now know, I'll tell you what are the advantages around the same in a couple of slides, but can't stop myself. But the manifest list will be able to tell you where the exact differences are being made, and which are the levels how many levels do I go down. On top of it comes the class teacher, the metadata files. I'm just trying to associate it with all of you so that we all remember this well. On top of it, we actually have the metadata files which are having the snapshots. The S0, S1 which you are looking at, they are the visible single table format which we are talking about, right? So you have got many data files. It will be very difficult for us to understand how do these files make a single table. I want to see it as a table. So these metadata binding up together, the manifest list together, makes a snapshot. And thus, it tells you, from here, when you look from the top, this guy, school principal, who is sitting on the iceberg catalog, when that guy starts looking at it, he sees that the teacher is standing, school leader is standing, monitor is standing, and all children are standing. So that is the view, and that is the concept of the data view that we are actually having here. So this is how the assembly of data happens on top of iceberg, if I can put it that way. This is a prayer class, and this is how it looks from above the stage, right? So on top of it, on top of the metadata files, you got the snapshot, and you then got the iceberg catalog. Right on top of it, here, the game changes. Multiple catalogs can now process your file, can see your file, can see your table, can access your data. And that catalog could be any catalog which works on your data. So now, who becomes powerful? The catalog game, right? So this is a snapshot which I managed to pull out, where let us say you have got S3 and you have got, I have this problem, okay. I need water. So once you have this iceberg table, so this is how it looks on your S3 bucket. So you must have already seen this, and all of you who work on AWS S3 know this. This is how your data looks like, your manifest file, your metadata file, your, the snapshot kind of a look. So this is how, so getting into the dirty job, right? This is how it would look like. And this is how your data is structured. So now what does it mean for you? What does it mean? Again, getting the value of the entire discussion, right? It means that you do not need to ingest your data anymore. Your data lies on your cloud bucket. Come on, man, bring your query engine, put it on top of it, bring AI, ML, MLOps, LLM, anything, and I'll be able to run it on top of it, okay? What is it not? It is not a storage engine. It is not an execution engine. It is just a view of the data, right? It is just table format, and it has got its own APIs, it has got its own libraries, and will be able to process the data. So that is the thing. Now I'll take one step further. You got the data, you need a query engine which has got the AI capacities, and that is where Snowflake comes into picture. This is a typical architecture, how Snowflake builds. The lowest layer is actually data, even before the LLM models and all of that come into picture. So we believe in, model garden approach. This is the only place where most probably you are going to see Anthropic, OpenAI, DeepSeek, all of them in one shot, including Meta. So once you have all of these models, you can build up specific functions. We have been talking about how AI is currently used to do the data engineering. So you can build those kinds of ML charts, and I'm going to show you how. Maybe if my laptop connects and I can run it. And the next thing which you also see is that on top of it, you see something which is structured data. So if your data is on tables, that is iceberg tables, or normal tables, or external tables, or any kind of tables that you have got the access to, you can build a chatbot and understand your data. Let us say you want to take it one step further. You want to process documents, .pdf files, .jpg files, .png files, and you also want to understand, like, chunk, vectorize, and then ask a question right on top of it. We have got something which is Cortex Search. You can build an entire RAG, which is a semantic and a lookup kind of a service. And Snowflake is also a vector DB. This is a large claim, but I'm making it here because we work very efficiently on the data which is currently getting vectorized. On top of it, you have heard a lot of the agentic AI, the agents and all of that. We have also built orchestrations on top of it. It can understand whether it should go for a structured data or an unstructured data, and which tools do I need to review. Once we have done that, we can build our solutions. We can orchestrate and we can build something with Cortex Analyst, and we can build an agentic system. Sorry. We have next slides also. So this brings us to the demo. I hope I can show that. How do I switch? Yeah, thank you. So this is a typical notebook on Snowflake, and I would like to run you through. This is how the snow site looks like. What we are doing out here is we are accessing the iceberg table, like I was just now showing. This is my iceberg table. I have named it as demo, and within that I have built, it might take a little time for loading the objects, but let us come back to it. It has got all the product reviews, right? I am building a sales intelligent agent, and I'm today going to show you Snowflake, how does it make, it runs on 3 tenets, okay? One is making it easy. You have always seen very complex solutions. What if I tell you, you can do this really quickly and it is easy? Second is efficiency. And third, very important, though ignored, is trust. You must have had sessions on responsible AI, trust, governance of data. All of it comes tied up in Cortex AI and Snowflake. So coming to the data set and coming to the iceberg table kind of a format. So what happens is I'm just setting up external volume to my iceberg table. This is all that you do, right, on top of Snowflake. So this is the connection point which is between Snowflake and my AWS S3 bucket. Once I've done that, what I would do is I'm just creating an iceberg table for the demo. I have already created one. What I would do is, once it has been successfully created, I would like to understand what is the data that is currently sitting in my table and what does it have in my product review. And I would like to first insert or ingest some data and see that this data moves into my AWS S3 bucket and is displayed to you. For today, because I was not sure if I would get the network or not, that is why I have run this statement. Pardon me, I usually run this along with you when I run the demo, but because of keeping a backup. But yeah, be with me. I have run this. I have done the ingestion. I've done the insert. After I have inserted and my files have been successfully created, I would go back and see. Okay. This is what I was actually expecting, but it's okay. I have a backup. The backup is here. How does it look like, right? Okay. So you would see the data, something in this fashion. So you would see that after you saw the demo, you would come to something of this sort, which would tell you that this is where your table exists and the product reviews exist, right? I just hidden my ARN completely, but you still saw it in one place. Once I've done that, and you have run your data, and your iceberg table goes and sits on an AWS S3, now what happens is that you are just getting a session. This is where the charm of Snowpark, running Python on top of Snowflake, comes into picture, and you are actually doing a complete schema setup, and this is a struct. There's a structure which is getting, so I'm just trying to show you here the different types of formats that can be processed right on top of Snowflake. Once we have done that, and I have got the data frame, and the data frame processing happens, I would have to run this. I would check, I would see I would play with fire. Let us see if it runs. Once your data frame has been processed, you would actually get the results out here. And you would also understand that once you have got, let us say, we can also do CI/CD, that is continuous integration with the data set which is sitting right on top of your AWS S3 bucket. It writes from Snowflake. Snowflake works as a query engine, yes, but it also can do the changes on the on the block store that you have. So that is the entire pattern that we are trying to build out here. And on top of the data set that you have now ingested, processed, you can now see with the help of data frames, you can run something which is called as our Cortex LLM functions. What does it do? I am trying to find out what is the product name, what is the review, what was the sentiment associated with a review. You got a review, wow, your product is awesome. I loved the, the product, the chocolate which was sent to me. Someone else could say the chocolate was really bad because it was stale, something of that sort. You need to understand. So sentiment falls between -1 and +1. So -1 is really bad and +1 is really good. So that is the sentiment. So here, when you see the review sentiment and different numbers, it means that there is some product against which there are some positive, some neutral, and some negative sentiments which are coming up within the product review. Once you have done that, you would also like to understand what is the updates that are currently, okay, connection is a problem. That's okay. What happens out here is that you can build, as I was mentioning, you understood your data better, you ran a LLM function which does the sentiment analysis, and then you are also creating a pipeline around the same. This is where I would call all the data engineers on you. This is where you would run a schedule, you would do a cron, understand how the data is getting processed and updated. Once you have done that, you can understand how your updates happen. And post the same, you can execute a specific task to do a continuous integration. And after that, you can actually run complex queries. The SQL review query, as you can see here. So you must be seeing in this notebook, there are 3 things which you can do. You can process on SQL, you can process on Python, you can use CPUs on Snowflake or GPUs on which we have got from NVIDIA on top of Snowflake, and you can do a distributed processing. Anything of that that is fine. And after you have understood, that this is the sentiment distribution, these are the SQL, these are the reviews that we have obtained across months, across our products. Let us see how does it look in our, let us say, the graph, the bar chart, so that I can make more sense of the data. So this is how all of the story comes in and stitches in together when we are talking about what is the data which comes in. So I also had a demo screenshots. And let us say you would want to run the specific thing on top of Spark engines. Then I just hope it loads. Yeah. On Spark engines, you can also do this data frame kind of analysis from the same files which we have, and you can actually manage the data set, and you can process the similar kind of a sentiment analysis from Snowflake. So Snowflake is a very, very powerful query engine which does all of these activities, and that's it from me. I would love to take a few questions if you have any today. Thank you.
Hello.
Hi, thanks for the session. My name is Vedanta. I'm from StoneX Group, and I work as a data engineer. So I've heard of this open table format called XTable. So I know that Snowflake supports it, but I just wanted to know, like, how does it differ from Iceberg in a couple of points?
There are multiple open table formats which are currently existing, and ultimately, when you walk the route, you would find that the entire philosophy of this open table format is to process the data which is existing in your own tables, and each of the open table formats are trying to make the ACID transactions, the CRUD operations, much more faster, efficient, and usable across catalogs and across query engines. So that's the ultimate aim. But if you ask me what is the difference, honestly, it's a very, very early time for me to compare between what Iceberg has and what X has and what is the interoperability. Of course, there is interoperability, but Iceberg and X both are free communities getting current updates from their developers and a lot of things which are coming in. I would call upon you, if you would like to experiment on Iceberg tables, please continue and please contribute to the community back. It's a open source table format. Yeah. Next question. Hi.
Hello. Thanks for the presentation. It was lovely.
Thank you.
So the question I had was in the slide I saw there's a mode where you put append. So often the problem is you have to upsert the data, right? Like you only have to get the certain parts of data. So what I noticed is even though we take a small portion of data and then we merge it, then also it does a full table scan. So like how do we go around this problem how do we address this kind of issue where we reduce the time proportionate to the data?
Yes, absolutely. This has been a continuous problem with almost all table formats that we have been, whether it is Hoodie or any of the other earlier table formats, right? So, of course, we have got two concepts, which is copy on write, merge on read kind of a concept, which is also applicable for Iceberg tables. How we are trying to do it is because of two layers of metadata that I just showed you, who are standing guard to your data, there are different, so there is a snapshot. Let us say there is an update which happens, the manifest file changes, the manifest list changes, automatically the snapshot changes, the single view you were getting, the path is changing, right, even with smaller merges and all of that. So because we have got two layers of metadata, we are in the process of doing some tweaking at the metadata level and still showing the snapshot kind of a object or snapshot kind of a objective, so that the merge on read, copy on write or smaller merges are more efficient on Iceberg. So basically it is a trial towards making, because of having multiple metadata layers, making it much more efficient. That is something which I can tell you. You can read more about Apache Iceberg. Just go to Google, search Apache Iceberg. It's open, and you can honestly go through all of this. There are a lot of beautiful concepts which have also been implemented on Apache Iceberg to make it more efficient, and both cost-wise and small merge-wise, and also larger data accesses, which have also been a challenge in earlier formats. Any other questions? Yes.
Great presentation. Love the product.
Thank you. Snowflake or Iceberg?
Snowflake.
Thank you.
So like I have a weird kind of question. So Snowflake is betting hard on Iceberg, right? It's an open source thing. But the last year, Databricks acquired Tableau. So like all the founders, PMC members are now in Databricks. So doesn't that concern Snowflake that like now Databricks has a hold on the open source project that can adversely affect the competition of Iceberg and Delta Lake?
Okay. Do you know how to catch a fish?
No.
No. What if I will catch a fish and give it to you? Okay. You will eat it for how many days? 1 day, 2 days, 7 days? What if I teach you how to catch a fish? How many days will you eat a fish? If you are a non-vegetarian, that is. Okay. I do not want to comment anything more on this, but you know how it works. If you know what is going on in your table format, the contributions that you are going to make, and then it is an open source table, and then I told you some big names. It is Meta, it is Apple, it is Netflix. I mean, think about it. Uber was also coming in for that. These are the people who have changed the game of data. I can tell you because I have worked on one of the largest tables existing today in the world, and I know the amount of data which is getting processed, which is getting processed every day, every hour, every minute. I can tell you that these are important concepts which are coming up. This would actually add a lot of variability to the system. I'm sure, in fact, I can also tell you Databricks has acquired Neon very recently for the AI part. But yeah, that's the game plan. But either you cook it yourself or you order it. Yeah. Okay, any other questions? My good friend.
Hello. Hi. So, with respect to industry acceptance, Sarita, so we know we hear the big names who have started with Iceberg and they're, it's working well for them. I just wanted to understand, even though the companies may have, big data, but they're, based on their modules, for example, commercial, sales, and other things, they'll be utilizing different cloud formats and different offerings. How is the industry acceptance on Iceberg from Snowflake that you're seeing? Is there a traction from a smaller industry as well, or is it just big players accepting it?
Let me answer that. Actually, I had put a slide there exactly to answer your question. At the last moment, I removed it. It shows the GitHub one. It showed the GitHub contributions, right, against of Iceberg versus another very popular open table format, which is which is Delta, and we were talking about those contributions. And when I said there are large contributions that are coming from multiple players versus Delta having a contribution from one player majorly. So that is one thing. So a lot of mind and a lot of thought process is going into building this solution. And the second question which you asked, like what is the adoption rate, right? So that particular slide actually, or those particular statistics actually showed us that it is actually getting adopted across the industry. Now with AWS S3 Iceberg tables also coming in, there is a lot of traction which is coming in into this data lake kind of a feature. Think about it. Your data still lies on the same place that you have had, and you can put in any query engine, and one of the best in the industry being Snowflake, and you can actually process your data right on top of it, and you can do ML, you can do AI, and a lot of other things on the entire data visibility set. So that's an amazing proposition to have, even for smaller setups, and of course larger ones, because they're sitting on very large amount of data. It is a go-to solution. So that's the answer that I can tell you. Okay.
Thank you.
Time's up. Thank you so much.
Thank you so much, Sarita, for that insightful session. If you have more questions, you can definitely connect with her outside the hall. Moving on to the next session. In this session, we'll explore how KnowBe4's agentic platform uses data and generative AI to automate cybersecurity configurations, reducing manual tasks, and making systems more efficient. AIDA, Artificial Intelligent Defense Agents, adapts to user behavior, offering intelligent risk reduction in real time. With over 16 years of experience in AI, cybersecurity, and engineering, Paras Nigam leads the generative AI development and India GCC strategy at KnowBe4. He has held leadership roles at McAfee, Forcepoint, and founded EdTech and service-based startups driving innovation and building successful teams across multiple regions. I request you all to please give a big round of applause for Paras Nigam, Vice President AI and Engineering at KnowBe4.
Hello everyone. Can we turn on the mic? Is it okay? Hello everyone. Thanks for being here. I think getting towards the end of the day. So I think she gave a great introduction. I will directly head into. I currently work for KnowBe4. I have been all along working for cybersecurity. Cybersecurity currently is at a very critical junction, I would say. With generative AI solving a lot of productivity problem for a lot of you, and it has created a new attack surface for the people working in the cybersecurity space. So typical traditional practices that we were using in cybersecurity, which were reactive in nature, are not helping us these days. And that's where we need to come with the proactive practices which have agentic workflows. And that's what we were trying to do at KnowBe4. around 2023 beginning, right? So in this session, what you are going to hear is our journey, how we enabled AI to help us build agentic workflows, and what was the data engineering that went behind it. A little bit about KnowBe4. KnowBe4 is the world's largest cybersecurity awareness company and now an HRM Plus company. We cater to around 70,000 plus B2B businesses across the globe, and we cater to around 100 million end users. So that's a little bit of KnowBe4. In terms of our product suite, we from security awareness to cloud security, and most recently AI defense agents. That's what we built over the last 2 years and shipped 4 agents last year. And I'm going to talk about the journey. So this talk is going to be mostly useful for people who are going through a transformation, how your company from a traditional typical data engineering practices used to empower your workloads, but now have to empower AI-based workloads and agentic workloads. So just to give a quick glimpse, right, 2022, where we were, at the bottom of this deck, you can see the purple bar here. It tells, we used to sell products. There were multiple products: phishing product, training product, real-time coaching, anti-phishing, right? Our customers used to take all the decisions and configure our products. That's where we were in 2022, and that's when the agentic AI boom happened, and we wanted to get there. So 2023 and 2024, around this is the middle layer this is where we are currently, and by end of this year we will be on the top layer. So what we did is we built a lot of agentic features, agents, basically 4 agents: risk score agent, generate phishing agent, training agent, and quiz agent. These agents helped us reduce a lot of effort on the admin side by taking automated workflows, putting them in the hand of AI, while admin is only responsible for taking core decisions, right? But this is not enough, right? We want to get to a situation where admin's workload are reduced significantly, and the decisions as well are moved to AI. So this is where we are heading towards, and this will be launched in 3 months from now. It's in beta testing phase for now. So for this, we have to move all the decision making as well as to AI. To achieve this goal, we need a huge amount of data, as you all know, right? Like, we are all data engineers in the room. We need to connect everything and build data. So where we were in 2022, we had KnowBe4 did not got built in a day. We are a 15-year-old company. We have built organic products. We have acquired companies. We have acquired products, and we have a huge catalog of product that came from different corners of the world, I would say. And what does that lead to, right? When you buy a product or acquire a company or you build something new organically, it's not always thought through from the eyes of connected data platform, right? And that's where we were. We had a huge data silos in 2022. But to achieve our vision, which I talked about, and where we are getting in next 3 months, we needed everything connected. If AI has to take responsible decisions, AI needs to know a lot about a user to make those decisions. So that's what we wanted to do, and that's where a little bit about data silos, I want to talk about that. So we had huge amount of training data. We have the biggest catalog in the world for the training videos and texts and images. We have millions of daily threat events that we ingest from around 30 cybersecurity vendors for all our customers. And we have millions of phishing emails that are sent every month to phishing simulation events, to correct here, not the real phishing emails, to all our customers. And then finally, we send millions of monthly training assignment to our customers. So this is what we do, and these all systems were disconnected to each other. So this is where the data silos lived in. So the charter that the data engineering team was assigned, right? There was a single charter, very simple charter to enable that vision, and it was eliminating the data silos and enabling all our AI with the connected data. So these are the few things. So this talk, I'm not going to go in depth of how we actually tweak those levers and build it out, but this is going to give you a workbook of how the transformation happens in a $5 billion company where you are handling data for 100 million users, right? So we got together, the data engineering team had to fix the problem which I talked about in the previous slide. And these are the 4 big layers, 4 important vectors that the team has to focus on just to enable the functionality. And in this session, I'm just going to go over those things which are enabling the functionality and not over the other aspects of data engineering which are equally important, like observability and making sure your troubleshooting things are right and all of that, right? Which I think a lot of other speakers previously covered. So we basically decided to build few of the things here, right? We built a data mesh. This mesh is currently in our first version. In fact, I have my data architect here who is working on the second version of the mesh. We build it, and I will talk about what technology we have used here. So this why we chose mesh. In fact, surprisingly, there were 3 years back, I heard about mesh here. I mean, I joined a session in this particular room, in this summit, and someone was talking about mesh. And that's what I recalled when we were doing all this brainstorming, and then we decided to, when we were comparing different architecture patterns, comparing lake houses to mesh, we decided to go with mesh. The reason being, we are a big company. We have offices, engineering offices across 5+ countries, different continents, teams working in silos. We cannot build a lake house that brings in data from everywhere across 5 regions that we operate in, right? So what we wanted to do is, we wanted to solve bureaucracy as well as technology problem, right? And that's where mesh helped us be the best solution out there, where data does not move, right? So with the core principle of mesh is, data is connected, but data is not moving. Data is still at rest. So the owners of the data still own the data. Data becomes a product for rest of the company. So that's what's a big transition we made after a lot of research, that we are going to go with the mesh architecture. And I'm going to share a little more details about what technology we used here. But the second most, not every use case that we were trying to solve will just get solved by a batch processing or a big data operation. We also provide those features that are very transactional in nature, and to power such features, we need data in motion. And that's where we build our own data pipeline. There were various teams using different services systems like SQS and RabbitMQs and various other stuff, but we built our own system called as DFS, and this enabled us timely delivery and also centralize the cataloging of all the data flowing across the company. So now we know what data is flowing from where. It solves a lineage problem to a certain extent, but that was not our goal. Our goal was to bring a centralized platform that helps enable billions of events to go through this stream. Then the third, I think the most important, while we are doing this, we are overhauling the whole company, right? It is very important to make sure that the quality is maintained. For that, we build our in-house SDKs for data validation for both mesh and pipeline. So before the data hits the catalog for mesh and it hits the DFS, there is a deep layer of validation that is mandated by the process as well as technology before it hits these. And the last one is data governance. So we, as a cybersecurity company, we have a huge responsibility towards our customer, because first of all, we are trying to safeguard them. We have to make sure that we also safeguard the data we own for them, right? And we have a very strong InfoSec team that does not allow any of my engineers do anything, probably. Not a great thing, but yeah. So we build huge amount of capabilities that enable InfoSec keep a watch on what is where, and also allow us quick decision making on building capabilities. Every feature that KnowBe4 rolls out has to be vetted by InfoSec, pen tested, and then we roll it out to our customers. Governance is a core part of anything that we roll out. Now, yeah, this is at a high level one of the workflows. I just wanted to give a glimpse of it, and which also gives you a glimpse of what technologies we are using. One very important thing, KnowBe4 is a AWS shop. We try to restrict to AWS as much as possible. We don't go outside AWS. We run probably a $2-digit million operation at AWS. So you can see the first leftmost section there talks about microservices. So there are multiple. So we run in production more than 2,500 microservices. I mean, multiple replicas of same in multiple regions, but these 2,500 microservices producing data and then have to churn out those AI features, right? So we build, you can see the second box there. I don't know how visible it is for all of you, but the second box, the pink box there, that's the DFS layer that we built. So the idea here is that each of these microservices are connected to DFS for all the transactional data. This particular use case is solving for a feature that is called as orchestrator and agents that we have released last year. You can see the 3 green boxes on the top. So what Mesh solves for them is these are all batch processing capabilities that we have built to power our agents and reporting capabilities. The data from each of these green boxes is available on Mesh. When I say data is available, data is not moved. That's the important thing here to understand. The data is cataloged, and you can see those blue boxes at the bottom. We are currently using Glue Catalog. We are transitioning to start using Unified Studio in AWS, which is their latest services rollout, and they are trying to bring everything together in the space of data and AI. So we are as a company are also transitioning to that. But currently in production, we use Glue Catalog, and then we use S3 to store our data in Delta formats. I think Sarita talked a lot about Iceberg. We evaluated Iceberg as well and various other components with other tools and technologies, and decided to go with Delta tables. We'll not go into details of why we did in this session, but this is the journey, right? These all green boxes, these are the 3 new green boxes, but all that leftmost corner that you see here shows all the microservices that exist, 2,500 plus services running in production, churning out data. So bringing all that data, cataloging it, making available on the mesh. Each of the services, you can see there is a bidirectional arrow here. The service can get access to the data through a proper governance, do whatever processing they need, dump it back and make it available on mesh. So it is again available across the company. So to build this, we have to build, as I talked about in the previous slide, there were 2, the mesh and the DFS enabled this, while we had validation in place and governance in place. So this is at a high level what we did in terms of technologies. At the last, you can see to enable a lot of our AI workloads, we're using AWS Bedrock, most of the part, and to make the data available that is sent as a part of prompts, again it comes through the mesh. So you can see the last box here, it's a data insight engine that fetches all the data from the mesh and that sends it out to the Bedrock. So that's about the production workload. So this previous slide, this slide talks about a workload that an application tackles. But to build any agentic workflow, there is a journey that the team goes through, and that the first phase of that journey, which is the most important phase, is the research phase, where our data scientists and analytics have to come together and work on identifying what is the best algorithms, figuring out what configuration they can make, and various other things. So to enable those analysts to get access to the data so that they can build the right algorithms, derive right insights, and prove the point that we can build those capabilities, this is the second journey that we went through. And you can see at the bottom, again, the microservice layer that existed initially. Then the data storage layer where we use RDS, DynamoDB, S3, Delta Lakes, all of that. So this was again consolidated with the mesh layer. There was a metadata layer creation on top of it through Lambda functions and also Glue there. Then the data was supposed to be catalog layer. So again, as I talked about in the mesh, we use the data Glue catalog there currently, and lake formation for governance. Then comes where the analysts have access to the second last layer. So this is our query processing layer, where we are currently using SageMaker and bunch of other AWS capabilities. And lastly, for visualization, we started using QuickSight and bunch of other tools, but QuickSight majorly because it was easily available. We have grown from here significantly, but this was our initial draft of the architecture that we enabled our analyst and data scientist with to make those key decisions. So that's at a very high level how we enabled our application teams and our analyst and science teams to help us build those agentic workflows. I think with that, I want to show some stats in my conversation. So these are few stats about Know Before is a HRM Plus platform. We have processed 500 plus million events in this platform that I showed earlier. We have delivered 500 plus real-time remediation events. So what is a remediation event? Whenever there is a threat that is identified by any of our system for any of our end users, 100 million end users, we deliver them a remediation event that helps them educate and mitigate the risk. We have delivered around 500K of those in last 6 months or so when we launched these agents. We have created 30K AI simulated phishing templates. So I think many of you would have received one point of time in your career phishing simulator by your organizations. We are in the business of doing that. Till now, what we were doing is our customers had to go to a portal, craft their own phishing simulation using our system templates, and then send it to their users. The level of personalization they could go with this was maximum to like 50 or 100 templates a year, because it takes a lot of time to get the template right and have all those red flags. Usage of AI, which was enabled through all this data engineering, we were able to, in the last 6 months itself, we have enabled 30,000 plus automated simulated phishing templates for our customers, where the admin has to do nothing instead of tweaking some levers to provide us the input for this. Lastly, I want to talk about a little bit on the success that we achieved through this is the risk score of our customers before we rolled out these features through agentic features was average score 41.5, while now you can see all the customers that are using these have already got down by 4 points, which is a huge success for a big organization, to 37.3, which tells the story of how agentic workflows are capable of addressing the risk posture of organizations better than manual human products, right? And lastly, 75% of the user do not repeat a failure. This is a big one. We realized that when we were sending these manual admin crafted phishing templates, there was a lot of talking between the employees and then getting to know what is it. And next time, the learning was not uptick, right? Next time there was again a phishing simulation sent over a month, and they would basically end up clicking it again. In fact, at Know Before, we have a policy: if someone clicks it 8 times, we just let them go. So these personalized agentic templates helped us achieve the goal of reducing the risk for our customers to a level where 75% of their users are now more clicking once they receive these personalized template, because there is no sharing of knowledge here. It's a personalized knowledge that they get. So with that, I would end my session here. Thank you everyone for being a sport. I can take a few questions.
Hello. Hello. Are you able to hear?
Yes. Go ahead.
See, I go through the entire your presentation, okay. But my expectation is you are going to tell something about cybersecurity under the hook of the data science.
Right.
But I don't see that at the
Correct.
moment. Okay, I'm upset on that. Because see, when you say AI agent on cybersecurity, so
Right.
my expectation is you are going to tell me something about the AI agent, how I build for the security point of view of data for entire workflow.
Right.
Like you talk about the data engineering point, entire thing end to end.
Right.
Okay. So that's want to see something from you. Do you have any build for like how you secure your data in the case of data engineering pipeline entire?
Right.
So if you talk about the data mesh also, right? So how you build with the security point of view or cyber security point of view about the data, how you secure, how you solve the compliance, GDPR compliance, PI compliance. So there is so many things in the cyber security or security come in the picture. So that's my expectation. I don't know.
No, so as I said, the expectation, this talk, this is a data engineering summit, right? The talk was not catered around cybersecurity, but it was catered about the journey, how a company goes through a transformation from being a company that has multiple products running in silos to building an agentic platform that connects all the data. So that was the talk around. But your point is valid. And as I talked about, right, data governance as the core component, as one of the 4 pillars that we focused on. So we sell, Know4 is available in all the continents. We sell to EU, one of our biggest international market outside US. And GDPR compliance is one of the biggest things that we cater to, right? So in terms of cyber security for data, I think definitely I would need another session to go, but we can meet outside the hall and I can share a lot of details around that.
Hello. Hi, here.
Hey.
So you mentioned that the agents are taking the decisions
Yes.
for the end consumer. So how did you evaluate the trustworthiness of those decisions before you roll out your end consumers? Can you show some?
Right. So basically, the algorithms, the agents are not completely built on GenAI based decision making, right? We are not prompting. We're not prompting, let's say, Claude model and saying that this user has this risk score and training. What do you think should be the next training assigned to this person, or what should be the next phishing simulation, right? There is a chain of, as I said, it's an agent, it's not just a prompt, right? So there is a chain of evaluation that happens. We look at the historical data of that end user. We filter out what education he has already achieved through phishing and training. Then we cater to what is the biggest risk on that user based on their self and their peers. And then basically that all data is consumed by our deterministic algorithms, which then helps us cater some insights. And these insights are then fed into the prompt to generate those phishing templates. So there is a journey that goes through, and that's how we make sure that there are in place guardrails to make sure that the prompt does not go haywire and start generating. I can add more details to it. So for example, we generate phishing templates. We do logo spoofing there. So you may end up getting a email which looks very much like Spotify. But can we send that, right? So we have a list of organizations where we are not allowed to do this. Like we cannot send an email coming from IRS to our customers and looking like it's a real email. So these checks and balances are in place. This is one of the example I'm giving. We have a huge chain of workflows just catering to B2C emails. That means emails that you get from companies like Spotify or India, for example, Zomato or Make My Trip, which are B2C. Then there are chain of phishing templates that you get from companies like, which are in B2B space, like Microsoft, right, and others. And there are different workflows that we make sure are in place, which provides our guardrails so we don't generate content which are restrictive, illegal for us, right? So that is there. Plus, on the data point of view, as I already explained, we have all these filtering and deterministic algorithms to make sure we have the boundaries.
So as I understand it, the problem you solved is building a recommendation engine for your analysts. What should be the next training to be provided?
This is not a recommendation engine. It does not go through the admin. It takes a decision, and those emails and trainings are directly rolled out to the customers. There is no human in the loop.
So then how do you comply with all the constraints you mentioned earlier?
That are all engineered in the system.
Okay.
Yeah.
Okay. Thank you.
Any other questions?
Any more questions? No, I think we're done.
Okay.
Yeah, can we please have a big round of applause for Paris?
Yeah. Thank you, everyone.
Thank you. Moving on to our next session. As machine learning systems grow more complex, the need for streamlined, reliable data infrastructure becomes critical. This session focuses on how a unified data platform can support the entire ML lifecycle, speeding up development, reducing turnaround time, and enabling faster experimentation through centralized access. bringing in experience from building large-scale cloud platforms and high-performance ad tech systems. The speaker has worked extensively on cloud optimization, scalability, and resilient architectures across global teams. Please welcome the head of MarTech Engineering at Wayfair India TDC, Senthil Kumar Ganapathy. Please can we have a big round of applause?
Thank you. Hello, data experts. Are you able to hear me? Okay. Happy to be here speaking to you about what we are solving at Wayfair India TDC. What we'll be doing is we'll start with a brief introduction about what Wayfair is, about myself, and then we'll jump into the problem that we are solving. Anyone here has heard about Wayfair? Okay, it's not a surprise that not many of you have not heard about Wayfair, because Wayfair as a company is not operating in India. We are predominantly based out of US, Canada, and Europe. But 2 years back, Wayfair set up a TDC in India to fast track the development of the technology. And now we have 600 plus engineers working out of India, contributing to the global Wayfair. What Wayfair is. So Wayfair was started as a single product company in 2002 by 2 young engineers, Steve Conine and Neeraj Shah. Neeraj Shah is an Indian founder. They started with one product, one website, and given the success of it, they kept on adding new websites for each product, and after a period of time, they had 100 websites, one for each product. And then in 2011, they consolidated all of these to Wayfair umbrella as one, all things home. You can consider it as a IKEA, but predominantly online. We do have offline experience stores, a couple of them, and then looking at setting up few more. So what makes Wayfair stand apart? It's the unparalleled list of SKUs and products that we make it available to our customers, seamless experience across online and offline, and value for money. We are also expertise in moving large items across the globe. As we are home, related to home, we sell large items like cots and sofas and couches and dining tables and whatnot. So we have proprietary delivery network which can seamlessly move items from one part of the world to the other. About myself, I have been associated with Wayfair for about 2 years now. I lead the marketing engineering team here, which also includes the data engineering team. Prior to joining Wayfair, I have been in the IT industry for 20 plus years across marketing and telco industries. So why UDP? So 1 year back, about a year back, we ran a survey with our machine learning scientists to understand what are the problems they are facing, what would make them more efficient. So one of the feedback, they had a bunch of feedbacks, but one of the feedback that was relevant to data engineering was the time that they are spending on feature engineering. So before I dwell into the problem, I would like to talk about what is a machine learning life cycle. Paris talked about the different stages of data transformation. He did mention that at one point of time it's also made available to analytics engineers and data scientists. Here we are, so most of the data platforms are focused on making the data available for analytics, business intelligence, dashboarding, etc. Right? Not many are catering this data to ML scientists. So every ML scientist have to, whatever data they need, they have to independently create pipelines to make their features. Going back to the ML lifecycle, ML lifecycle typically involves 4 stages. What we call it as a model engineering, model training, model deployment, and model monitoring. And if you think data scientists, they spend most of their time in writing models, that's not true. They actually spend a lot of time in analyzing, cleaning, transforming the data. So they want to make sure the data that goes into the model is perfect. So you would have heard about this in the data world. Garbage in is garbage out, right? So they spend a lot of time in making sure the data that goes into the model is perfect. So what they do is every time they have to come up with a new model, they come to the data engineering team and get a new pipeline created. And this takes about 4 to 6 weeks. And then when they have to create features on top of the pipeline, that takes n number of weeks, right? So we wanted to reduce this. We wanted to reduce the time taken for the MLS to identify their feature set and to make it easier for them to believe that the data that they are using is curated, good quality, has been cleaned, etc., right? So here we are talking about two types of data. We talk about a seed data and we talk about a feature data. Consider seed data as a primary key of a table, right? It's like in our e-commerce paradigm, what the user is. How are we identifying the user? Customer ID, device ID, etc., right? What the user is. What did they see? Did they see a product? Did they see a banner? Or did they see an ad on our system? What did they do with it? Did they just see the product? Did they add them to a cart? Did they purchase it? Or did they, let's say, return it? Where did they see it, right? Did they see it on our first page? Did they see it on an external ad? So these are primary data that is called the seed data about a user. The seed data is used to create features. What are features? Features are something like, what did the customer browse for the last 7 days, or 30 days, or 90 days, or 365 days? What did the customer purchase? Where did they purchase from? These are derived from the seed data. These are transformation, aggregations, and all done from the seed data. So from a seed data, hundreds of features can be created because you have a n cross n cross n matrix, right? Like on the 4 parameters, you could create an n cross n matrix. So the feature store is that. And then the model training, there are different kind of models. You would have known about it, supervised, unsupervised, etc. Here we are talking about supervised model, where the data, input data and the output data is labeled. Within supervised, we have classification, we have regression, vector models, and even neural networks, right? There could be different type of models. The ML scientist is going to select the right model for solving the business problem that he wants to solve for. And then he has the data now, he has the model, so he's going to iterate the model with the data and look at the output. Is it performing, not performing, and then tweak the features, add features, delete features, and look at the features and deploy and continue to monitor whether the model is continuing to performing as per the expectation, or is it drifting, and make changes to it. So this is the MLS lifecycle model. So what we noticed is each MLS scientist is going through this independently. There is no centralized feature store, there is no centralized seed store, and it takes up a lot of time. So what is the proposed state? So we wanted to create a centralized store for keeping all the seed data. So as I mentioned before, seed data is nothing but placements, customers, products, and actions, and then create features from it, create training data from there, and then all the MLS scientists can access this for their model instead of they creating it one by one for themselves. So how did we achieve this is something I'll be going deeper in the further slides. So before I go into the architecture, I wanted to quickly talk about Lakehouse architecture, given that we have all data experts here, I'm sure you would have already heard about Lakehouse architecture, but wanted to quickly touch upon what is Lakehouse architecture. So long back, when the data evaluation started, we had data warehouses. Some of the famous ones are Vertex, Snowflake, sorry, not Vertex, Snowflake, Databricks, etc. So they have tightly coupled memory or storage and compute. So the data is stored in proprietary format, making it easy for analytics to query the data, visualize the data, and then represent the data. And then we also had data lakes that were there for querying unstructured data, the data that is not structured. So companies came together to make a open source architecture which is called data lakes. This is from Databricks, but data lakehouse is an open source architecture that can be implemented by anyone. Here, it basically makes it easy for both the structured data and the unstructured data to be queried. It separates out the storage layer and the compute layer. So the storage, so that you are not tied up to any particular company. It's not a very proprietary format. So you could use a Delta format, or you could use any format for your storing the data, and you could use any compute to querying the data. And it takes the data into 3 stages. The first stage is where the data lands. So what we call it as a staging stage or a bronze stage, right? Here the data lands as it is. It is basically collected from multiple sources. It could be your in-house sources, or it could be even third-party external sources. Every data is collected and stored as it is without much modification. Here the whole idea is store the data as it is, so that if you want to go back, look at lineage, or if you want to go back and audit the data, and even sometimes rerunning the data if some of the downstream processing has failed, right? So you have the data in place. And then this data is then curated, cleansed, and like for example, there is a test data that we want to remove it, and we want to augment the data. There is a metadata available, and we want to join them, we want to filter it, and that is what is done at the silver layer. Here the data is usually in a third normal form. So this layer is also sometimes used by the analytics for ad hoc analysis. Even the data scientists may look at this layer. After this, the data is aggregated, the business logic is applied on top of the data, and then made available for presentation in aggregated format. This is usually the gold layer, right? And also the silver data can also go into a feature store. Now, what is missing in this whole architecture is this largely built for data analyst and not for ML scientist, right? So we don't see how I can generate features from here. We can put data into a feature store, but we rely on the feature store to do more feature generation. So we wanted to use this framework and build on top of it. So we came up with something called Wayfair Unified Data Platform, which basically takes the data lakehouse architecture, extends it to add further processing and platforms to generate the seed data and the feature set that I was talking about before. So let me talk about the details of these and what are the components that are basically available here. We logically separated it out into 2 modules. These are internal code names. We call the first one as Atlas, the second one as Horizon. In the first one, we have the first component is called fact gen, right? This generates the fact data. This is similar to what a data lakehouse output for a gold, at the gold layer, right? This actually reads from various sources, transforms, cleanses, normalizes the data, converts them to a star schema model where you have the facts and the dimensions, and that's made available in a store. We are a Google cloud shop, so some of these technologies that we use are from Google Cloud, but this is just a data warehouse. GBQ is Google BigQuery is what we use. Equivalent on any cloud is something that we can replace it here. And what we have connecting layer is all DAGs that are orchestrating, reading the data, transforming the data, aggregating the data using Spark engines, and then putting them into a fact table. This is largely static tables. There's nothing dynamic about them because we want to make sure that this is valid data that the data scientists can rely on. We are also, on the horizontal layer, we are also applying data quality checks to it. So many times we have seen upstreams misbehave, right? And that causes issues in the downstream. And many times we don't detect there was a problem in upstream, right? There is anomaly in the data. The field shouldn't have been having this value, but we got into a system. So Google has a product called Dataplex. We extended it basically to enable data quality checks. So you can add null checks. You can say this particular data type should be there. All of those checks are done at this layer. So it's actually done in each of the layer, but this is a layer. So that's a fact gen, right? So you have the fact data now. Now, based on this fact data, we generate the seed data and the feature data. So these two are dynamic because we want to make sure we are giving the flexibility to the ML scientist to generate whatever seed data they want, whatever feature data they want, and with a very less friction with the data engineer. So they don't have to come to the data engineer each and every time they want to create a feature. So the second and third boxes are more dynamic, and they are built in a way that they can be either scheduled to generate things on a weekly basis, or by a config can be manually triggered by a ML scientist. So I'll go into the details of how we did it dynamic. And just to complete the flow here, after the feature is generated, we load the feature into a feature store. In this case, we are talking about Vertex AI, which is a feature store provided by GCP. It could be any low latency key value pair store. It could be Redis, it could be Aerospike. But Vertex AI provides certain other functionalities such as governance, RBAC. You could be letting only few data scientists, ML scientists access some of the data, not all the data. And then you have the ML scientist notebook that is accessing the feature store, and then using that for training the model. So I'll be talking about how did we make the seed gen and the feature gen dynamic. So here what we are doing is we are generating dynamic tables. These tables have to be generated dynamically, and these pipelines have to be triggered dynamically. So these are not static tables and pipelines. So we have come up with something called a dynamic SQL generator and a schema validator. So we want to make sure the SQL is generated dynamically. There is a template which is parameterized, and then there is a set of configs that has the different actions that can be taken, like join, etc. And once the config is applied on the template, the SQL generator generates the SQL, and then it's validated to make sure the SQL is having the right schema. Once this is done, it's picked up by the DAG. It could be Airflow DAG or any other DAG. In our case, we are using Composer from GCP. But before that, we want to make sure the schema of these SQL tables hasn't changed a lot, right? The schemas have to be well within the schema definition. It cannot, there are certain rules for a schema. You can add a column, but you can't drop a column or rename a column because there could be some other MLS scientist using those columns for their models. So there is a schema definition, there is a schema management engine, and then there is a schema validation. These two are applied, and DAG runs on them and creates the seed table on GBQ. So this is how we are making the data dynamic, and making it self-serve. So if a MLS wants a new seed data, they could come and change the config. They can pick up the input data, they can pick up the output data format they need, put it in this config, and trigger a DAG, and this will be automatically uploaded to the GBQ table. So we spoke about FactGen, which creates the fact tables, SeedGen that creates the seed tables. Then we have a module called FutureGen. So we have a module called FutureGen. FutureGen reuses the dynamic SQL generator and the schema validator. It's just that FutureGen uses seed data to create features. And this could be, as I mentioned before, this could be a lot of combinations of seed data. Many times the scientist needs hundreds of features. They want to evaluate all of them. So a combination of a user versus a product versus the action versus the page in which they took the action, as I mentioned before. FutureGen, it's just that instead of generating the seed data, it generates the feature data. We'll talk about what is the feature generation flow, right? So it starts with triggering the pipeline. The pipeline gets triggered either periodically, because the feature has to be refreshed on a periodic basis, or manually by ML scientists coming and changing the config. So then it loads the config, checks whether this config has schema changes or not. If it has schema changes, then it has to go through the schema definition and schema validator to check that if this schema change can be allowed. If it can be allowed, then it goes through the generating the SQL queries. And SQL queries are generated from a template and the config, as I mentioned before. These SQL queries are validated. If there are issues, then they go through an error. The queries are executed, and after execution, the features are validated again. We want to make sure the features are good enough. Again, they go through data quality checks to make sure the features are good enough for the MLS to use. It is prepared to uploading into a feature store, and they get uploaded to a feature store. Could be Vertex AI. What are some of the benefits of putting this data into a feature store? So we could make it available in GBQ or a data warehouse as it is. Feature store provides certain benefits, right? Basically, it can provide a auditability. Let's say a feature has changed and we want to see what changed in the feature. We can go back and check. There's audit, time-based audit, or a config change-based audit. It can give us different versions of the same feature. So the MLS can create different versions, test different features, and then use them as needed. It can support governance, as I mentioned before. We want to apply RBAC and say that this set of MLS needs only this data. Let me give access only to this data, right? And it could also support online and offline data. In case of the others, it could be only batch processing. We can't do online. So it's usually a low latency serving system, so it can be used for both online and offline models. This is the system has been is almost ready now. So we are doing a demo with our ML scientists next week, and we are looking at taking it for adoption. So we are hoping that this is going to solve their problem and increase the velocity. Wayfair is like a $14 to $15 billion revenue company, and we spend upwards of $1 billion on marketing per year, and we want to make sure our marketing spends are as efficient as they can be. So we create a lot of models. We run a lot of experiments. What is the right image to be shown to the user? showing, we have seen that just showing a different image from the catalog to a user in the ads have shown improved performance. Changing the color of ads, overlaying ads with certain text showing that this is a Wayfair verified product, there is a sale running on it, and all such things have helped. So these are experiments we run continuously. To run these experiments, we need the models. For the models to work fine, we need the good data. And for the models to be iterated very quickly, we want to increase the velocity of the ML scientist. And that is what, as a data engineering team, we are trying to help. Many times, the data engineering team end up serving the analyst or a Looker dashboard or a UI. I invite the data engineers here to start thinking about how they can contribute more, how they can contribute to the data scientist or the MLS. Like these two terms are used interdependently in your organization, and increase the value of what you can give to your organization. So that's about my presentation. I think I'm just on time to take questions. Thanks everyone for listening to me. Open for questions now. Sure. Yeah.
Hey Sandil.
Hi.
Thanks for the talk, Shalin. This side from Amex. I could relate to the problem because we solved exactly the same problem a couple of years back. So different modeling teams solving in silos, then an enterprise platform came together to solve this.
Yeah.
We also built a feature store just like you showed. But one challenge that we faced with the feature store was, since there were multiple modeling teams solving for different kind of ML problems, they were creating just same features but with little tweaks, right? So at some point we ended up in a feature store where it's like the name of the feature itself is the same, but they've just tweaked little bit to fit their context, and we ended up like having duplicate features. So how are you planning?
Yeah, so there is a point that I kind of missed to cover here. Good that it's a good question that you asked. So we have a concept called feature family or feature groups, right? So what we do is we group all the features that are similar, like the small tweaks that MLS wants to make, and then we kind of store it in the same table, and so that all the related features are stored together and the MLS can use it instead of they creating newer names. And we also are giving a standardized naming convention to the features. So when someone is coming and looking at the feature catalog, they can look at the feature name and search for that feature and see if it's already available and not create it again.
Thank you.
Thank you. Any other questions? Okay, great.
Mike.
Thanks, everyone.
Is there a question?
Yeah.
Anyone? No, right? Okay. Yeah. Okay. Thank you so much, Sandil.
Thank you, everyone.
Can we have a big round of applause? Now we're moving on to our last session. Thank you for being such a patient and wonderful audience. Our last session that takes us into the heart of next generation data infrastructure, platforms that are unified, reliable, scalable, and increasingly AI-driven. In the fast-paced worlds of crypto and DeFi, data isn't just a byproduct, it's a core asset. And harnessing it in real time with precision and intelligence can be the difference between leading and lagging. In this talk, we'll explore how automation, data quality, and AI-powered insights are redefining how businesses unlock the true potential of their data. To take us through this transformative journey, please welcome the Vice President of Data Engineering at CoinDCX, Prakash Patidar. Can we please have a big round of applause?
Thank you all. So my name is Prakash. I am based out of Bangalore, and currently I'm working at CoinDCX. So people who have not heard about CoinDCX, just in case. So CoinDCX is a crypto exchange and DeFi platform. And I mean, we have almost more than 15 million users, and our vision is to expand that and give access to for the crypto and Web3 assets to the masses. And we know that the world of crypto is little complex because a lot of regulatory and things comes in between, right? It's not just like you go and do trading on Zerodha. So a lot of things come, so we wanted to make it as simplified as possible so that it becomes the mainstream asset class for the masses. This company has been started by like 2 IITians, back 7 years back, has become unicorn in 2021, and it has on paper more than 2 billion valuation, but actually in reality it's way more because this is based on last funding. All right. So about me, like I have almost 20 years of IT engineering experience. Worked on different companies, like mostly I worked on startups. Sometimes for the sake of changes, I worked on enterprises also, just to understand their problem statements and how they are differ. And since last 10 years, I'm in data engineering field. So I love building large-scale data platforms, and things are evolving rapidly. But what is most important is like what thing passionate me more about is like solving the critical business problems and through data so that it can add huge value. And of course, in my personal hobbies, I love swimming, farming, and programming. So like this activity I can do any time of the day. Yeah. So today, like I am going to cover. You people have heard a lot about like on the data. Maybe there is some overlapping, of course. But what I'm going to cover is like what are the key fundamental ingredients which we must keep in mind. That is like I learned from my experience. Like we make a lot of mistakes, build something, and then iteratively we came to some platform, right? So what are the key ingredients for the success? And then we will deep into some architecture patterns, and then probably towards the end we will look some of the use cases which we have solved through like AI and ML, right? Okay. So next time coming to, of course, like any kind of a build definitely should start from the expectations, like what matters for the business. If we align to that thing, then it becomes very easy for us. Then whatever technical fantasy, it goes away. Like I simply say, like, and then you simply focus from the business perspective, right? So some of the key things which we look into is like, first is of course data democratizations. We know that we are in the world where it's not about one unit transformation. We are looking for all around transformation. And to give all round transformation, what is important is like to have access to insights and informations at fingertips for all your business units, including like, and how can you empower each business units to take the data-driven decisions. That is the first thing. Second thing is like, how can you add value to your product? How can you give value to your customer? Because the moment you start giving the value to your customer, you start growing, helping to grow the product way faster and give the competitive advantage. So that is super important. The next thing is like today, like everybody needs real-time action, and I'll tell you, this is not something which is sort of a want, but this is more about need. If I relate to like my own industry, like if we delay in identifying, like for example, in crypto exchanges, when we list a token, new tokens keeps coming, right? So we can't just list the token. We need to do like, there is a lot of background processing which happens behind the scene before listing the token, because we need to safeguard the user's interest also. At the same time, we wanted to give the full opportunity to our user, and many times when you don't list the token on time, then you lose the opportunity, you lose the business, and many times you lose the user also. Many users comes to the platform because of certain things, right? So it's very important to act on time. Even like same time, it is important to delist the token. In our world, like we need to delist also. Like if something new scenario comes, then we need to. So there is a data-driven decision always, right? So how can you make that actions as fast as possible? And that is completely depend on your data platform. Even like if somebody has access to your kind of because we have like decentralized platform. In decentralized platform like Octo, if somebody has access to your wallet, and it's a self-custodian things, right? So then in that case, hacker can take a lot of funds away from you, right? So that is where we play a critical role. Like we have multiple defending layer, and then how do we identify fraudulent transactions in real time, etc. So many use cases where real time is super important, and not like in the crypto industry, but across. I think this is becoming a need. A competitive advantage, of course, is like data is the biggest weapon we know, and what is most important is like making data available on time with full quality and then across. So then it becomes the competitive advantage. So that is super important. This point is also like, we know that there is a huge data literacy across the unit. Like people can use the data, they understand like, okay, if I need to take that decision, they understand from their business units like what is important for them. But it is difficult to, scale your engineers or business analysts to that level. Like for each person, if they require something like programming people or like somebody who writes SQL, then it becomes very difficult, right? So it's very important that if the information is available at fingertips in a way where, when the information is required, you deliver it. Like, you break that barrier, information barrier, which comes because of technology. So, that is important, self-service analytics. This is also important because all the decisions, like I took multiple examples, like when we take the real-time action. So all these things are actually dependent on like data. Like, so whatever data you are providing, like what is the quality of data? Because you collect the data from so many different places, and you have huge responsibility before bringing the data into action. So that is this thing is super important. Then of course, like many of you might have heard, like everybody like business comes to you and you want like these features today, like that way, right? So like making a platform in a way where you can do a rapid delivery. I'm not saying everything, but like a lot of things you can do it. Like once you started building the patents over the period of time, then you can help business in rapid fashion. Cost efficiency, of course, like this is very important. Like ultimately P&L matters for the business. So we can't go crazy on the cost. Security and compliance, because being a centralized platform, this is super important for us. So now we know these are the business expectations. So now we'll move into like what are like some of the critical elements which we must have in our data platform. Many people have, I think, discussed on unified data architectures. I'll not go in much detail, but I think I mean of having is like centralized platform. Centralized in the sense like processing-wise it's distributed, but logically you see like it's centralized, so that you just need to connect to one. Like internally you have so many systems, but you just need to connect to one and get the information. Real-time data processing, as I explained, like the importance of why business is looking for. So there you have to have a place completely, like it should not be integrated in sidelines, but it should be part of your core stream where, if new use cases comes, you can plug in like, so a lot of streams are coming. Real time, maybe you don't need to act on one stream or two streams, it may be multiple streams. And then also you need the additional data to augment before taking the decisions, right? So all these things requires a proper thought process in the platform. Next is AI ML ready design. As we discussed today, like a lot of things has been discussed on AI ML, but it's very important that whatever data platform we are building is like for all round transformation. So this is a part and parcel of the game. So how do we build things which is completely usable and we can do a rapid innovation? Because one of the our responsibility is to fuel innovation in the business, so that way we can always get the competitive advantage. Of course, scalable in the sense many dimensions. Like we see the volume grows over the period of time. We see use cases grown over the period of time and it gets crazy. We see, so basically your number of users can grow rapidly, right? So all these dimensions you need to be scalable. You need to think about like how can you make systems super scalable. Of course, data governance is important because you have unified platform. That means like it's very important like what informations, what insights to be shared to whom, right? So that level of governance has to be there. Security has to be there, of course, because data, because a lot of data movement happens in the platform. So whether data is at rest, data is in motion, data is there, PI data, so many things are moving pieces, right? So how do you ensure that data is completely secure, and you know that what accesses are given, plus enough auditing also in the system. Cost efficiency, of course, in the era of cloud, like it's very easy to go infinite scale theoretically, but ultimately it hits to your bills, right? So every places the cost efficiency is super important, because as and when like more and more data means easily your cloud will go very high. So this is, I'm just placing here a blueprint of the architecture. So basically, this can vary depending on, but fundamentally I'm just trying to say like this component should be modular. Modular, why I'm saying is like each piece, like any piece we think, because we are building the future architecture. So future is like every time it is evolving. So any piece which comes in the market, which is like, best in class, then we can easily replace it. Why to have architecture where, it should not require us to, have a lot of changes. If I need to replace, for example, here compute, storage, or like any kind of a data ingestion layer, so I can do it very easily. Like that should be the motto. If you see the architecture from left to right, so all people needs to deal with the sources. That is true. Like so, like for us also, like we need to deal with a lot of sources. For us, there are some kind of a messy and very high volume sources is also there. For example, in blockchains, when we need to get the events from blockchains, the informations are not like the way it is. Like you need to do a lot of curations before you get the information. But what I'm trying to say is like, when you start doing these things, so ultimately the number of sources over the period of time grow rapidly. What is more important is like, if you see, the patterns are fixed. If you identify key patterns, like be it like what level of interfaces it is providing, be it pull, push, what is the formats, what is the variety, what is the angle of like whether when you are getting data, let's say for example you are getting data from API, or you are getting data from some operational databases, or you are getting real-time streams. So there are well-defined patterns. So once you code for the pattern in your data ingestions, then your job is super easy. Like that is where I'm saying rapid onboarding of new use cases. So when we need to onboard use case, means we need to onboard data also many times. So when you onboard new data, your platform should support. Like so, if you see control plane there, so we should have something where we can rapidly onboard. Like for example, I need new data for my new algorithm. Okay, here this data could be external data, internal data. It could be competitor data. Anything is possible, right? Then we have something, even like at the ingestion also, you should have something which has a huge number of connectors, or like if you are doing something in-house for a specific purpose, so you should localize for that purpose. Otherwise, it becomes your innovation, I think, get limited, like in terms of like, so many places you can get the data in a matter of minutes these days. So why to miss that opportunity? Then now the middle part, if you see, the middle part is like the core heart of the system. If you see, like there are 3 layers: compute, storage, and your governance layer. So we know that we want to have decoupled storage and compute, fine. So in compute, your fundamentally you have stream processing and batch processing. When I say stream processing, it could be absolutely real time or near real time, depending on like the use cases, and then batch processing. So the point over here is like, when you, let's say new business case comes, then how efficiently you can place those use cases on this platform is very important. So like for example, is it that simple, like you go in and put new logic there and rest up, because stream processing anyway has the, consider like you build in a way that streams are coming, you can place any rules over there, and then you can get the data from your storage also, and then you can say like, okay, now after that I want to do this. So you define your sort of a source, sink, and logic, and then you can apply, like, and then there are additional things which you can apply in terms of how frequently you want to do, etc. So that should be fundamentally there. As regarding the storage, like you see, like there are multiple boxes over here, and basically over the period of time we have identified also, if one size doesn't fit all, right, so we need to have something where we can host all sort of a data. We welcome, like, be it coming from blockchain, structure, unstructured, at scale, like, because this is the era where we do ELT, not ETL, right? So we wanted to keep every data, and we want something like reliable, cheap storage. So that is where the lake plays the huge role. Because here, it's very important that you don't know, like, today you want to do this processing, but tomorrow the new use case comes, and you don't want to miss on the data. So data is there for everything. Then, of course, like, when you want to have sort of a curated information, then you want to have some sort of a warehouse where you can provide information well curated, and then to your serving layer very easily, in terms of speed, in terms of quality, everything, right? So that is where the data warehouse will play a role. Many times what we do is, like, lake and warehouse, we combine these two things, which is fine, but architecturally we need to know that, okay, when I say like warehouse, then what is my expectation in terms of the queries should run in that much time, it should have that quality of things, of my data. It will require a lot of business modelings also, so that those kind of things will come into that. We discuss on like AI ML ready, right? So basically when we build all these things, it's very important that we use the reusability in mind. So this feature store addresses, like before this session I was listening like to build the feature store and efforts, right? So it's the same features. You building sort of a feature group family and start sharing the same feature. So this brings the consistency, this brings the rapidly onboarding new systems, new services, and also it reduces the time in terms of the turnaround time, because your features are mostly ready because it's a part of your engineering itself. Then fourth thing is like there are multiple analytics we do. Like when we see like serving layer on the right side, so we do a lot of things, not just BI, right? These days, a lot of trends are like where you do user-facing analytics. Like for example, we do like LinkedIn, Facebooks, they do, right? So how do they do it? Like, so they don't go like, so basically the challenge is very different. There, the number of users who are accessing your system is not in thousands, it's in million. So then you have to have that level of concurrency in your queries. The response time is very different. When user is waiting for something, it means you can't hang him for like even couple of seconds. Then it requires sort of a sub-second response. The information also, accuracy of the information and freshness is also super critical. So the challenges varies. That's why we need to have different systems in order to serve those kind of things. Now, the bottom layer, if you see like where we are talking about, irrespective of multiple systems, but what we are giving to the outside, this is a packaging. What we are giving to outside world is like, no, they don't need to deal with so many complexity. They have to have some sort of a catalog where you can see information, you can search information, you can discover information. There is enough context in that catalog where somebody can see like, okay, what are the information which is of mine use, right? So that is where the data catalog will give like kind of a unified catalog. Then lineage, of course, is important because you are doing a lot of transformation, a lot of streams are coming, then you are applying computations, cleansing, and all these things you are doing. So how the data has reached to a final stage, how do you see it? If some problem comes, then you can always troubleshoot, look, identify problems. So the lineage is like very important from that angle. RBAC, of course, if you wanted to apply any kind of a governance, because we are saying that this is a unified layer, you can access the data, but who can access what, you can always control through RBAC. Audit, this is like post thought in a way, like for example, if somebody is doing something with data, so every actions are being recorded, so you are doing audit. Now you can use some kind of a model to identify if there are some threats. Threats could be in any form, right? So you can, once you audit, then that is possible. So like this is the middle layer. If you see on the serving layer side, BI, we know that whatever is readily available, dashboarding, reporting, monitoring, alerting, everything is coded there. But self-service analytics, as we discussed, on the fly we can give the insights. For example, user comes, like, stakeholders comes and they wanted to see like what happens to my business, why there is a drop, why there is a like sudden failures in the system. So all these things is possible, provided you provide, because for everything you can't code and create dashboard. But a lot of things where you require sort of a self-service analytics. So this plays a critical role into the ecosystem. Then data science, as we discussed, like we need to have execution environments where data science team can access the data, they can do exploration, they can experiment, they can do hypotheses, they can build the models, they can run, identify the features. So that kind of execution platform is required in order to get to the objective. And then once the data science team are like, they know that this is actually connecting to the business, then the next thing is like you require sort of a ML ops kind of things where you can actually productionize your model, and then you can control. I mean, there are so many challenges which comes when you productionize the model. Once after that, there is a possibility of model drift. You need to continuously evaluate the performance of the model. So all these things require a proper kind of a pipelining over there. Then reverse ETL, like for example, this data is not only for like in internal information. We wanted to use this data across, like we wanted to improve our product experience, we wanted to improve our user experience. So the reverse ETL is required. So this is all about the architecture. So far, I'm taking a little bit pause, but just in case if you have any questions, we can cover, and then I'll go to the use cases further. We can cover it last also. All right, so the next is like, yeah, this thing I think I didn't thought of like, but many people have discussed a lot on like how can, so basically data is feeding a lot to AI. Without data, AI is not possible, and vice versa, like now AI ML is also transforming the way we are doing data engineering a lot, right? So as we discussed self-service analytics, how can we use AI ML to do a self-service analytics, which we discussed, right? We can use, these days like off-the-shelf models are available. You can use those models to actually, earlier it was very difficult when you do NLP etc. The quality was, I mean, not at that scale, but today, I mean, how do you, basically a lot of things are connected. Like how do you organize your data, and like as I said, cataloging also is super critical. Like when, let's say you have enough context about your schema, enough context about each columns, definitions, business meanings, your whatever jargons you are using within your business, because a lot of things is related to your business. So if you have enough information, then self-service analytics is possible. Then you can build the model on top of that, and somebody asks questions and you can transform these questions into SQL, not just SQL and then provide the data, but then on top of that you can provide the reasoning. Reasoning in the sense like, for example, you see there is a funnel drop. Like for example, you have a customer journey starting from sign up to onboarding to making deposits to do first trade, right? So eventually that journey, so you can see like why funnel drop is happening, what is the reasons, and it can answer. I mean, you don't require analytics team to build the complete thing and find out, because it takes a lot of time, right? So that is possible, provided like how good we did the cataloging. That is where I'm saying semantic cataloging is pretty important, and AI is helping a lot in this case also. Like, so understanding, not just understanding how the column name has been given, but also you can use the AI in order to understand the data and use that to feedback, like give the enough context and semantics to your data so that your metadata layer becomes very strong. Feature of prioritization. So basically, here also AI ML is helping a lot, right? What features play a critical role? Query optimization. I mean, like these days, like I'm sure like you people have gone through that phase, like people are coding through AI, right? Not just coding through AI, they are also doing review through AI. Like somebody is writing query, what we see, like what is the possibility of optimizations, etc. So all these things, but it really depends, like when you are taking a model and how much, let's say whether you use RAG approach, whether you use prompt tuning approach, or whether you use model fine tuning approach, either of them. But how you're utilizing your data is super important. Then your answers will be correlated. So I mean that becomes pretty important. Now some of the use cases we can look. So I will cover. Okay, so I will cover one use case then quickly. So basically this is like customer chatbot. So every business has some problems, and then eventually customer, like for example, you did some deposits, right? And your deposit is not reflecting in your wallet, or you have questions like how to do some activity. So for all these things, we had a chatbot, but whatever chatbot we had was like more like flow driven, like a lot of graph. Let's say for example, different business flows and rules has been given, and then customer is going through that journey in order to find out the answers. But that chatbot had some fundamental problem. A is like discoverability, like to reach to your solutions, it takes a lot of time. Scaling agent, when some problem comes in crypto world, what happens is some failure comes, then it fails to so many users. It impacts a lot of users. Then all the users will come for the support case. Then you don't have that many human agent. It's not possible to scale human agent. That is where, how can we use AI in order to solve that problem? And then third thing is response time, of course, because human agent will take time to provide response, etc. So this kind of things was actually a problem. To solve this, we use LLM, but it's a very different journey, because we started with something, then it didn't work out, then we gave in iterative fashion, then we crack the problem, like, okay, to use the LLM, what exactly we need to do it. It's not like when we say multi-agentic, like we need to, actually ultimately it's all software engineering. So you have to break down problem in a very small pieces, like scientifically. So like, for example, first user comes with some problem. So you know also within your data that what user has done, what is the possible problems of users, you already know, because you have data in real time. Now user chats something, then you identify intent very quickly. It is very easy to, if let's say initially when user chats and you provide the resolutions, so that is if you try to solve a complete problem in one go, then it is very difficult. The accuracy of that model will be go on toss many times. So you need to break down that in multiple pieces. First you say like, okay, first I will identify a problem. Once you identify a problem, then you may have n number of different flows, but you then have multiple agentic approach and different models which is specialized for that problem, and that model is like equipped with your data. Then, so basically you are going in a systematic way. So this way we try to solve it in short, like we reduce agent handover rate a lot. Like, so how do we measure our efficiencies? Like, if you, like 1,000 users has raised the request, how many has eventually lent to agent, human agent? Our objective is to protect our human agent and then solve the problem also. It's not like protecting human agent means like customer is not happy. So we need to measure the customer satisfaction also, and we wanted to, so that is what we were trying to achieve, and we achieved it. And this is how, like, so multiple problems we have solved, like, but like just to give this. So taking a pause here and opening for question answers. Yeah.
So recently, Vajirax has a cyber attack.
Yes.
So how Coin-D6 is protecting itself against cyber attack?
Yeah. So exactly. So basically, when you are in this game, the problem could be like, as I said, like we need to identify. So basically, if somebody is actually doing crypto withdrawals, right? That's the biggest risk. So if somebody is doing crypto withdrawals, it's not like if you come to the platform and we give the crypto withdrawals like infinite. There is a systematic process, and that systematic process is based on data. So we take a lot of data. Like for example, we look for, like, if the customer has just arrived and then he's looking for a lot of withdrawals, we will not give it. Then, I mean, there are your transaction patterns, your trading patterns, your wallet activity patterns. We ask for certain proofs from you also. We look for risk score and full KYC. After that, all these things, what we do is like, then only we enable certain withdrawals. That is one. Second thing is, our assets are like, whatever our assets are, that is like behind, would say like it's a trusted in n number of forms. Like, so basically there is a security team within the Coin-D6, altogether a separate department, and any kind of a code or designs which goes through that. So any kind of things has to cross through them, and then a lot of tools in place which protect. So basically you've seen that is the biggest trust factor which should have on this kind of platform.
So what is the mistake that Vajirax has done? Like that's why like hacker was able to get all the withdrawals.
Yeah. So basically there was a they did a malicious attacks in order to identify like potential leak in the wallets where they keep the fund, right? And it was like systematic thing happened like for the couple of times, right? So basically they first identify the loopholes by actually putting I would say like it's a combination of multiple things. Like, so when the excess of the system has happened, and once they know the key part of assets, right? then they started withdrawing it. So basically, it's a sort of a open. I mean, not one thing. Their assets are not secured in a way like whatever keys, etc. Because in world of blockchain, you know that everything is like dependent on your keys, how you are protecting those keys, where you are keeping those keys, etc. Right? So they have access to that keys, and that is how they withdraw all the money. All right. No question. Thank you.
Thank you so much, Prakash. And that brings us to the close of day one at DES 2025. A huge thank you to each one of you for your energy, curiosity, and engagement throughout the day. We hope you're walking away with fresh insights and inspiration. Before you go, don't miss out other sessions that are still happening in the main hall. And at 5:45, we have a special stand-up performance by Sapan Sharma. So wishing you all a great evening. Thank you. This is Vandana Nair signing off.